Everybody, I'm happy to introduce VB, our next speaker. He's a machine learning advocate at Hugging Face, and he's going to talk about Hugging Face for local machine learning AI. If you have any questions, please ask them on Slido. If we have time, we can take live question at the end. So VB, floor is yours.
All right. Whoa. OK. Can you hear me? OK. Awesome. Brilliant. Hello, everyone. I am VB. I do everything that needs doing at Hugging Face. Not sure if you've heard of Hugging Face. Who knows what Hugging Face is? Nice. I love building stuff with local LLMs. And what I do at Hugging Face is essentially build glue work tools and scripts that help make these tools work better together. What is this talk about? This talk is about on-device LLMs, on-device machine learning, and what you can do with it, what is possible with it, and more specifically, what does the process of sort of creating these models look like, and in the end, what are some things which may go wrong, and what are the things that Hugging Face and I are quite excited about when it comes to the landscape. All right. Quick disclosure, I prepared for this talk to be 45 minutes long, and I just got to know that it was 30 minutes long. So bear with me. I'm going to do some live coding stuff, and hopefully things would break, and we'd have some fun. Cool. So how many of you have run a LLM on device? All right. How many of you used Ollama before? OK. How many of you have used llama.cpp before? Nice. OK, brilliant. So just to prime everyone, what we're going to do is we're going to try to sort of run an LLM on browser. OK? And the hope is that if everything goes well, then we'd essentially give an issue to the LLM, and we'd ask the LLM to create a structured JSON out of it. Right? So we'll say that, hey, I'm having issues with, I don't know, the login page. And this is unstructured data, with random things. And then we define a JSON schema on the left, which essentially is what's the title of the issue, what's the description of the issue, what's the priority, and so on. And we hope that the LLM does its thing, and we get a structured output in the end. Quick caveat, the LLM in question over here is running just on my browser, right? So we load the LLM on the browser, and then we ask it to do its LLM things, right? Cool. So as you can see over here, oh, that was fast. I was hoping it was slow. Anyway, so what happened here is over here, it took this text, right? And the text over here is the login page is not properly handling password reset requests, blah, 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 blah. So it creates a title, which is error, password reset request not being resolved. It gives a description. It gives a label, bug, security, whatever, priority high, estimated time, 1 week, and so on. Just to prove that this actually works on my device, here's some quick stats. What you want to look at is this memory usage and GPU usage. So hopefully, when I click on generate structured issue, you would see a spike in the yellow bar, which means that it is actually using the GPU compute on my laptop. Fuck. Oh, my God. OK, wait. Thank you very much. OK, let's see. Hopefully, it works now. And oh, come on. Actually, woohoo! So again, everything essentially works on the device. And this is where the LLM just messed up big time. It's estimated time, 1 full stack trace tracing, identified, blah, 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 blah. Well, hello, my sweet child. But well, it's a great demonstration of what you can do with just a tiny 1.7B model. This is what, a gigabyte in terms of your RAM usage. And it takes unstructured data, fits it into a JSON schema, and gives us a nice issue preview, and so on. So this is actually already possible now, running on your sort of Chrome browser. This also means that you don't need to deploy an LLM. You can just like offload all the compute at the edge, right, itself. Cool, let's go back to the boring stuff. Please work. Of course. Amazing. OK. It worked. So how does one run stuff like this? There's like a plethora of like tools, apps, frameworks, libraries, and so on. The first one being llama.cpp. This is like the bread and butter of on-device machine learning. You have OLlama based on it, LlamaFile, LM Studio, like pretty much anyone who does like on-device sort of machine learning uses like some form of llama.cpp embedded. Then there is MLX, which is more specific to the Apple ecosystem. There's like MLX LM, there is MLX VLM. There's, again, LM Studio supports it, local chat supports it, and so on. So just for context, these are ways that you can run these models on device, right? Then there is Onyx runtime. This is brilliant, sort of both runtime as well as like downstream libraries from Microsoft. Then there's TVM, which has been around for a while, and they have like web GPU support and so on. So the demo that you saw before was from WebLLM, from like TVM folks, and like the whole demo was powered by web GPU. Then there's Whisper.cpp, and the whole plethora of like VLLM, TGI, SGLang, the libraries that you would use for on-device or just on your like CUDA-based runtimes. Cool. But then, what else can you do with this on-device thinking? Let's try to do like a quick demo with like everyone, since everyone has been talking about like model context protocol and like using these using like different sort of disparate tools, functions, and sort of different servers together. Let's see like what we can do with like local models, model context protocol, and so on. This is where comes like a really small library that we recently released. It's called Tiny Agent. What it does is as it says, it's like a less than 100 lines of code. It's a library which allows you to connect different tools to LLMs, and you can just run it with, like we have a TypeScript client called Tiny Agents. We also have a Python client, Tiny Agents, and you can just create very simple workflows and use local models, deployed models, OpenAI, Claude, whatever fancies you with this. So let's try this. OK. So as always, like you can see the GPU usage here. And what I'm going to do is I'm going to deploy like a very quick LLM server using llama.cpp on my Mac. This uses like Qwen 330B parameter model. Hopefully it would load. And when it loads, you would see like that the memory usage sort of spikes up. Load faster. Maybe not. Take your time, it's fine. Perfect. So you can see that the model is now deployed, and like it uses like some amount of memory. I am cheating a bit because like this is the full spec'd out Mac. It has like 128 gigs of RAM, but you can do this with like a 8B model, 4B model, 2B model, and so on as well. Cool. Let's try and do some fun stuff now. So to get things started, let's try and see if I can use a Hugging Face space. Let me open a new tab. So a space can be oh, I opened the model. Well, I can go here. So let's say there is this space which creates images based on text, right? So I can say Dogo Ghibli. Hopefully, at some point, it would run and give me some sort of output. Hey, it works. Now let's see if we can without telling the model explicitly to use this, let's see if the model can figure out to use this space just from my CLI, right? And hopefully create something. Cool. Let's go here. So I created like a quick workflow for this with tiny agents. What it does is, this is local image gen. So I created like a very quick prompt, and I say, you are an agent, do whatever the hell the user tells you, and like in the end, just say that, help the user create high quality images and so on, right? And then I defined like an agent.json, and I give it my local endpoint, which is, whatever, 8080, and then I pass it the URL of the space, which is an MCP server in this case, and nothing else. So I just give it I just give the MCP URL of the space itself, and then let's see, how do I run this? Wait. Okay, so then I do like npx, Hugging Face tiny agents, run local image gen. Again, you can do this with the Python client as well. I just didn't have the time to set up like a virtual env and so on, but it's literally the same experience. So as you can see that the agent is now loaded with one tool, which is the Flux Schnell in this case. And so let me see. Of Labrador, Ghibli style. And I'm just going to give it, like, I'm just going to throw it off itself and say, make it 1024 x 1024 in dimension. Now, hopefully, if the demo gods are with me, we will see some fun. So you can see that the model is thinking now. You can see that the user wants to create an image and so on. This is the model sort of like thinking, like figuring out which tools it can use. Then over here, it figured out that the prompt should be a Labrador in Ghibli style. The dimensions are this thing. So the width and height of both are both like 1024. This is all like a local model, like doing its thing. And it thinks a lot. And over here, it's making the tool call. This is where the chances of it messing up are the highest. So now we wait. Maybe it works. OK, so over here, you can see that it did a tool call, and it returned like an image URL. Let's see how this image looks like. Oh, so we have we have a nice sort of image of a dog, Ghibli style. It is cute. OK, so this is something which is like already working. And you can see that my code actually just terminated with an error. But it's fine. Doesn't matter. Let's try and do like something else. Let's try and ask it. Actually, let me see if the server is still on. Is it? Is it not? Maybe? No? Let's turn it on again. And now let's try to do like a local search. So npx. So now I want to ask it to search like huggingface.co and give me like maybe like the list of top 10 models. Let's try and see. Let's ask it to what? My R stopped working. No, it works now. Okay. So let's say that I have a search agent. So I give it access to my computer via like Playwright, which is another MCP server. Again, the model URL, I give it like a local model path. I give it a prompt, and this time I change the prompt to like follow the instructions given by user, think which tools you can use, whatever. Cool. Let's go here. Let's do again. And run search agent. Cool. So now you can see that it has loaded like 25 tools. It's like browser close, browser open, install, all of that good stuff. And hopefully now it would know how to open a browser, right? So let's give a very simple prompt: find top 10 models from on Hugging Face. Hopefully, it should be able to open a browser. Let's see. Okay, so it's like you can see that it's thinking, go to this browser. It automatically opened the, huggingface.co/models. It opened the Chrome browser in this case, and let's see where it is now. So you can see that it essentially it did browser navigate. Then it went to this page. It got the HTML of it. That's the URL. That's the page. It got all the information about it. And that's a lot of information about it. And then you keep scrolling, keep scrolling, keep scrolling. And it's still thinking, because why not? Hopefully it would work soon. OK, this is great because it errored out. I don't know what else to do right now, but anyway, so essentially you can see towards the end, it says therefore the answer should be the list of the models from the highest number, and it gives some examples. Ideally, if it works fine, it gives you top 10 models. I don't know why it's not working right now. Sorry, demo gods. But all of this code is on my GitHub. It's called Experiments with MCP. You can find it, and we can see. That's just a quick way to show what these models are capable of. Typically in companies and so on, you would be using OpenAI compatible models or OpenAI models, Claude, from Anthropic and so on. But you can do a lot of these just with open models, which are probably a fraction of cost, and for local workflows just work directly on your laptop. Cool. So but what do you use these models for? These local models, first of all, you should use them for really small atomic operations, which means let's say you want to rewrite, let's say you want to translate, let's say you want to convert unstructured text to structured text. Use local models for it. You really don't want to use really large models for it. If you want to use web GPU, now everyone has access to sort of good machinery, and so if you want to do I don't know, background removal, you want to do I don't know, run LLMs on your website and so on. For that, web GPU stuff less than 4 gigabytes, browsers can work quite well. For offline use, this is a very important use for sort of governmental use cases, wherein you have air-gapped laptops, servers, and so on, and you don't have the luxury of having OpenAI calls or Anthropic calls and so on. So for those, it works quite well. For tinkering, testing workflows, it's quite well. It works quite well just to get an intuition of how things work, and for a bit of profit. Cool. Now, couple of facts just to show how the landscape of on-device machine learning is from Hugging Face standpoint. As of today, every month we service roughly 5 to 6 billion pulls of these large language models or machine learning models from the Hugging Face hub. There are close to 230,000 large language models alone on the Hugging Face hub, which people are using. And these are just public. I don't have info to private. There are 120,000 sort of Llama CPP, OLama specific models that you can use. And on any given day, we service roughly about 7 petabytes of bandwidth per day. Thank you, AWS. Yeah, so now that we know that these models are used, we know what we can use these models for. How does one prepare these models? First of all, you pick your desired LLM. It could be a fine-tuned LLM. It could be a pre-trained LLM. It could be your Llama, Quen, I don't know, DeepSeek. Pick your favorite. Then you check if it's supported in Transformers, which is a library, again, also by Hugging Face. If it is supported in Transformers, then check if it's supported in llama.cpp, MLX, Onyx, blah, 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 and convert. Once converted, assuming it converted properly, wipe check if the output of the converted model and the original model match. If that matches, double check if the chat template works. If that works, then profit. And this is all like a really involved step. Like sometimes it takes days, sometimes it takes weeks, and so on. And this is like typically me, like explaining to a research group or like one of our clients. Is like, this is how you make like a model run with like llama CPP, OLama, pick your favorite poison, like VLLM, and so on. Sounds simple. What could go wrong? Well, really, what could go wrong, right? Well, you could have like wrong tokenizers. This typically happens when you have a new model. Tokenizers are the one which convert like, because your LLMs just understand numbers. They don't understand text. So tokenizers are what like maps text to like these numbers. You could have just the wrong mapping. There is like more on like transformers level, like you could have like issues with rope. You could have like chat templates. Everything goes wrong when it comes to chat templates. These models could be multimodal, which means that they take audio in, they take image in, they take text in, and so on. And maybe your laptop doesn't support it, whatever. It could be a new architecture like DeepSeek or like Qwen and so on. That could go wrong. Yeah, here's some of my colleagues like fixes to llama.cpp. This is when like Llama 3 was released. Thank you, Zuck. And there was an issue with tokenizer. And this was actually like, fun fact about this is like as soon as Llama 3 was released, essentially exactly at that point, Pedro, my colleague, shout out to my man, he opened a PR to fix the tokenizer for Llama CPP, and you can see from the reactions that people were like, "Thank you, Pedro." Then when DeepSeek released DeepSeek v3, as soon as it was released, like the community got behind it, and like there was this PR because DeepSeek was a mixtures of expert model. You don't need to know what MOE is, but essentially it is different than normal LLMs. When there were Qwen-based like distilled models, there were different tokenizers and so on. Also, shout out to Georgie, who created llama.cpp. If you're listening to this, great job, man. Cool. So how does Hugging Face contribute to all of this? Well, we have the Hugging Face hub, where we have millions of these models, and you can pull these models for free. Thank you, AWS, again. We have like a core set of libraries. So there's transformers, there's tokenizers, safe tensors, Hugging Face hub, lots of stuff that goes, like lots of stuff uses it like internally. Safe tensors is like the safest way to like, have your models. We have specialized libraries for running stuff on Onyx, Neuron, TRTLM, lots of that. We have a plethora of on-device libraries. We have Candle, written in Rust, transformers.js for JavaScript, also a bunch of like CUDA-based stuff. We have converter spaces. So the whole process that I listed here, you can now just go to like a space on Hugging Face Hub and just like convert models without having to worry about all of this. And we're also core contributors to pretty much all libraries that exist and have anything to do with LLMs, which is Llama CPP, VLM, TGI, SGLang, and so on. Love all of them too. Cool. So you might be interested in like how these models are progressing on the hub. Like it's sort of like good to understand like how the adoption is, right? So more number of models created means more adoption of these models, right? So just like Llama CPP or like OLama cons in this case, like you can see that there's like a quite nice and steady sort of increasing trend. Like that's essentially number of models created monthly just from one space. Like actual models are much more than this. And you can see that it's like it's kind of like increasing quite nicely. If you look at MLX, it's going through what I call like a pretty much like a hockey stick growth. Like MLX again is like a way to run like models directly on your Apple on your Apple devices from the Apple team. It works quite nicely. Quite bullish on them. So on. Last slide. What am I most excited about next? So I'm quite excited about Llama CPP, like essentially having streaming tool calling support, multi-model support. I'm excited about transformers having a backend in TGI, VLM, and SGLang, which means that you just use one definition of these models, and like you can run it across different runners. I have been like, I have spent like significant amount of time in the past 2 weeks on model context protocol, and I think like it's like the way to sort of like augment your model with different tools, search, just access to like a VM, have them run code and so on. Then more accurate sort of quantization schemes than we have right now, and of course like leaner and easier packaging. That was a lot. Thank you very much for listening in, and happy to take any questions if you have time.
Okay. Thank you. Great talk. So we have a few questions on Slido. Let's try to answer them all. Probably we won't. So first question is, given your extensive experience with local models, what is like your preferred trade-off between quantization and model size? So like, would you prefer a 14 billion parameter model at 4 bits or an 8 billion parameter model at 8
That's
bits?
a question which I get all the time. So typically what I would do is I would look at how much VRAM I have. So let's say like I have 30 or 32 gigabytes of RAM. Then I would try to find the biggest model I can fit in 32 gigabytes, right? And then like try to go like down the quantization layer. So like there's Q8, Q6, Q4. Do not go below Q4 unless like someone forces you to. Anything above Q4 and the largest you can fit, choose that. Hopefully that answers the question. Otherwise, find me outside.
Okay, then we have, are tiny agents intended to be used locally, or can they be served for model remotely?
Yes, so Tiny Agents actually was built for like remote only. It's only because we are quite passionate about on-device models, so we added like the support to do like on-device. But you can use it with like all like remote models, OpenAI, Claude, whatever it may be. The code is actually like really, really lean. Like it's like less than 100 lines of code. And the idea behind it is to just like give people a space to tinker around. You can also use it in like production and so on as well. It's very simple, but yeah, both supported.
Okay, great. Then let's go with this one. You should access to the browser. How can you make it like safe to access the browser with a model?
Well, yeah. So essentially, like we use Playwright. So there are multiple ways to it. So we use like Playwright, in which case like you give it access to the browser. But typically, like in a production setup, what you would do is you would have VMs, right? So you would spin up VMs on the fly. You would give the access of the VM to your model. Like E2B is a very good example of that. And like you have the model essentially mess up in that VM and not on your laptop. But I like to play life on the edge, so I just gave it access. But typically, you would just use a VM and spin it up. They are cheap. Use them.
Okay. A couple more. So what's your machine specification? Does Llama 30 billion parameter require strong equipment?
Okay, yeah, I should have bought my other laptop. But this one is like a fully spec'd out M4 Pro, M4 Max, whatever. But you can, like my other laptop is like a 24 gig. Like you can actually use like very small models as well. Like you can use like 2B, sort of 3B, or like 6P parameter model on a very simple MacBook Air. Like the cheapest MacBook Air would also work. Or just like get like your own like sort of CUDA device and so on. But like there's really like no issues with using smaller models. Like you can use any, like you should be able to use, for example, Tiny Agents with like a Llama 1B as well quite easily. Hope that answers the question.
Okay, then more philosophical question. Do you think open source models serve as an alternative to proprietary models, or are they more of a competitor?
100%. I feel like I'm a big proponent of open source models. If I cannot see the if I cannot see like the tensors, then there's really no point of using it for your production workflows. We've seen like time and again that be it like OpenAI, be it Anthropic, they keep on changing the model in production. Like one day it would be working, the other day like the same prompt would not be working. I like having as much control as possible, especially if I'm putting these models in production for like my clients, my customers, and so on. So I think like the initial cost of onboarding open source models or open weights models is a bit high, but it's so much more worth it to use those if not. And as also Simo Wilson, Django guy, also says that if there is an open weights model, then you can build stuff on it, and even like 10 years down the line, you would be able to recreate it because you have the actual weights of the models, right? So use open source models. If you need help, reach out to me. Yeah.
Okay, great way to end the talk. We don't have time anymore, so we need to finish this now. Thank you very much for
Thank you.
this.
Paolo, si vede male di là. Guarda, si vede male. È voluto? C'è un problema video? Sembra. Si vede viola, di là. Viola e verde.
Avevo visto solo quello là. È morto? Sarai tu nel caso il portatile? Sarai tu nel caso il portatile?
Io sì, faccio. Ok, è andato, ok.
Sentite?
No.
Io sì. Si vede così. È lunga, Questo lo chiudo? Vediamo, ok. Perfetto, scusate il ritardo, ma ci siamo. Allora, benvenuti a tutti. Oggi faremo una chiacchierata con alcuni componenti delle comunità locali di Python, ovviamente, in giro per l'Italia. Sono solo alcuni, ce ne sono tanti altri che magari stanno facendo servizio di volontario qui alla conferenza, li vedrete con la maglietta gialla, e ringraziamo anche loro. Siamo una rappresentanza, non gli unici, insomma, attivi in Italia, quindi ringrazieremo, vedremo anche qualche immagine. È il secondo anno che come community cerchiamo di promuovere le persone a unirsi a noi. Questa è la foto dello scorso anno, come vedete c'è lo sfondo di Firenze, e abbiamo fatto il primo banchetto con una cartina che vedete lì. Io passerò oggi semplicemente la parola ad alcuni rappresentanti delle community locali, e vi parleranno di quello che loro fanno comunità per comunità. Ognuno fa cose leggermente diverse, tutti fanno magari un talk, una birra o altro, però ognuno ha le sue peculiarità, e è un valore aggiunto avere tutte queste comunità in Italia. E abbiamo le slide che non coincidono con la scaletta qui sul palco, però troveremo pian piano tutte le foto. Allora, questa è una foto che abbiamo appena fatto, e quindi già si vede che siamo cresciuti in questo anno. Sono molte persone che si sono unite nelle comunità locali, che sono venute ad aiutare e che sono venute anche qui alla conferenza. Quindi un po' l'obiettivo di avere tante comunità locali è vero fare comunità localmente, ma anche di accrescere la più grande comunità di Python Italia, che è poi quella che è l'associazione che ci aiuta tutte le comunità e fa in modo che siamo qui. Allora, invece di andare in fila, noi faremo questo giochino. Passo la parola a Matteo, che si presenta al microfono.
Vai.
Mi sentite? Sì? Allora, sì, io sono uno dei coorganizzatori di Python Marche, che è probabilmente una delle ultime community locali nate nella nostra nazione, in Italia. Siamo nati in forma embrionale e in incubazione a luglio dell'anno scorso. Per qualche mese siamo stati come i pulcini, con un gruppo Telegram, e nel giro di poco tempo ci siamo affiliati a Python Italia. E l'idea del primo incontro che abbiamo svolto a settembre dell'anno scorso, il primo meetup, è nato un po' semicitando Benito Urgu, mangiando, bevendo, bevendo, mangiando. Perché forse vedrete anche qualche foto scorrere, si mangia e si beve spesso negli incontri delle nostre community, quindi i momenti goliardici sono anche quelli più coinvolgenti, magari, ecco, così. Solitamente facciamo un incontro al mese, dove ci vediamo solitamente di persona. Ci è capitato una volta per raccogliere degli speaker che venivano un po' da fuori, che non riuscivano a raggiungerci in zona, di fare un incontro anche online. Alterniamo a volte, ecco, però principalmente ci facciamo questi incontri di persona, dove con un paio di speech, 2 speaker
abbiamo avuto anche l'occasione di invitare speaker da fuori regione, ci sono venuti a trovare, però ecco, siamo un gruppetto di organizzatori, siamo 4-5, la maggior parte ci trovate anche nei corridoi della conferenza, a parte qualcuno che per problemi personali ecco, non è riuscito a raggiungerci, siamo Carlo, Amanda, Jorg, Luigi che non ci è riuscito a raggiungere. E siamo un bel gruppetto di organizzatori, nel corso del tempo, negli ultimi mesi si è creato un piccolo zoccoletto duro, chiamiamolo così, che ci aiutiamo a vicenda ecco, a organizzare i soliti eventi. Quindi la formula principalmente è quella di 2 speech, dopo l'incontro ci spostiamo a mangiare e bere qualcosa insieme.
Allora aggiungo io 2 cose, visto che non le dette. Allora, Python ha fatto anche un esperimento di incontro online che è andato abbastanza bene, ha invitato gli speaker da fuori e penso, a differenza di altre, si sposta spesso come città, Ancona, Pesaro, magari se una volta non riuscite ad andare a San Benedetto, magari a Pesaro vi rimane più comodo, quindi è interessante come formula.
Esatto, se ho 30 secondi volevo aggiungere una cosa che mi sono dimenticato, perché probabilmente siamo, se non la mosca bianca, la mosca grigia, insieme a Python Campania, che abbiamo questa ambizione a fare un po' di coprire un po' il territorio un po' più ampio. Ma le Marche, per esperienza pregressa, le community locali c'è troppo campanilismo, probabilmente, non lo so, i numeri anche non sono grossissimi, però con è vero, ti devi spostare di un po' più di chilometri, ma i tempi di percorrenza alla fine si avvicinano a quelli di una metropoli, quindi adesso il problema dello spostamento nella regione è relativo. E in più facciamo incontri itineranti cercando di raccogliere ecco, un po' di attenzione, di interessi in giro per le città delle Marche, anche nei borghi storici, molto interessanti e carini da andare a visitare.
Confermo, perché da Pescara abbiamo fatto una spedizione ad Ancona, il Freccia ci mette un'oretta, anche da Bologna vicino, da Milano, altre parti, quindi se siete interessati a provare la pizza Rossini di Pesaro o altre specialità, vi consiglio di andare, è una bella esperienza. Grazie Matteo, passiamo la parola a Torino.
Sì, ciao a tutti, io sono Simona e sono qui in rappresentanza del gruppo di Python Torino. Io in realtà ho iniziato a far parte della community un annetto fa. Prima di me c'erano già 2 ragazzi che non sono qua purtroppo in conferenza anche per causa di forza maggiore e quindi sono qui appunto in rappresentanza. Il gruppo si sta insomma allargando, adesso siamo in 6 diciamo come nocciolo duro e come organizzatori. Diciamo che noi organizziamo 2 tipi di eventi, da una parte facciamo più talk o workshop, sempre dopo l'orario lavorativo. Di solito il taglio che cerchiamo di dare col workshop è una piccola introduzione teorica e poi una parte più hands-on, invece può succedere che ci siano delle serate più a tema e in quel caso magari si portano degli speaker che parlano di quel tema. Invece l'altra tipologia di eventi che facciamo si chiama Datamorph, che è un'iniziativa che nasce in Spagna da degli sviluppatori e data scientist spagnoli che hanno detto perché non ci troviamo, beviamo una birra e ce la raccontiamo. E dopo che hanno iniziato a farlo tra di loro hanno pensato ma perché non ci facciamo sponsorizzare da Estrella, e quindi Estrella Dam sponsorizza il Databirds e lo sponsorizza anche a Torino, quindi noi ci ritroviamo una volta al mese, un mese facciamo più l'evento appunto workshop più diciamo Python Torino vero e proprio, e invece il mese dopo dopo facciamo il format sempre Databeers, quindi Python Torino per Databeers, in cui è più lightning talk, quindi in quel caso cerchiamo di invitare 3 o 4 speaker che però tengono insomma, dei talk molto molto brevi, c'è tutta la fase di networking poi dopo. E nulla, direi che queste sono le attività principali che facciamo su Torino.
Perfetto, grazie Simone. Passerei a Milano.
Ciao a tutti. Ho visto. Ciao a tutti, sono Emanuele, sono l'ultimo organizzatore di Python Milano, sono qua a sostituire Cesare. Noi facciamo, le nostre attività principali sono 2 serie di eventi, uno è PyData, che è più concentrato sulla parte di data science, e l'altro invece è Python Milano, che è più sulla parte di software engineering. Abbiamo poi anche un podcast, si chiama Intervista Pythonista, tra l'altro l'ultimo episodio è lo speciale PyCon, quindi se volete andarlo a vedere è su Spotify e Apple Podcast. Allora, noi credo quest'anno abbiamo fatto più che altro lavoro di back office, nel senso ci siamo molto concentrati sullo stabilire un processo organizzativo che sia più o meno definito, appunto per riuscire a pompare fuori 2 eventi al mese con una certa regolarità. E diciamo, abbiamo avuto degli ottimi risultati perché siamo riusciti nell'ultimo anno a non saltarne quasi nessuno, che per me è stata una cosa abbastanza importante, nel senso che comunque Milano ha sicuramente il vantaggio di avere più grossi numeri sia in termini di aziende che in termini di sviluppatori e potenziale pubblico, però credo che sia anche abbastanza nota un po' la proprietà disgregante della città. E quindi niente, è molto bello che dopo i meetup praticamente tutte le volte facciamo pure una cena che segue l'aperitivo di networking classico, e diciamo un bel momento perché sia per fare networking con persone nuove, dato che al posto di stare lì un quarto d'ora con la pizzetta in mano hai 2 ore in cui parli con le 4-5 persone che hai sedute a fianco, e quindi hai più occasione di costruire rapporti seri, e anche essendo riuscito ad avere un certo grado di frequenza e stabilità, è stato molto bello vedere sui mesi il gruppetto, magari le 3-4 persone che all'inizio erano timide, poi li vedi che pian piano fanno il gruppo, e anche se no semplicemente vedere che creare un luogo che diventa il punto di incontro magari per ex colleghi e questo genere di cose, che appunto è un po' il core del community building. E anche avendo un processo così un po' più strutturato siamo riusciti sia a ridurre l'overhead cognitivo per gli organizzatori già esistenti, ma anche poi a crearci una base documentale un po' più comprensibile, così che stiamo adesso abbastanza attivamente cercando di espandere il team di organizzatori, che sta andando abbastanza bene, spero. Guardo lì Carlo, che è uno dei nostri fondatori. Così, queste direi sono le cose principali.
Ok, grazie mille. Io ho dimenticato di presentare la community di cui faccio parte, quindi salvo un attimo, parlo anche di Python Pescara. Noi non facciamo nulla di tutto ciò, noi cuciniamo e andiamo in montagna e basta, a Python Pescara. No, scherzi a parte, ovviamente come tutte le altre community abbiamo iniziato su suggerimento di Python Milano, diciamo il capostipite delle community italiane, a fare le PyBeer, i talk e altro, però abbiamo cercato anche durante l'estate, Pescara solitamente è abbastanza caldo, quindi fare il talk, chiedere alle persone di stare sedute è difficile, di coinvolgere le persone a fare attività insieme, giustamente solo per fare networking. E quindi, visto che abbiamo la possibilità di andare anche in montagna o al mare o di cucinare qualcosa, è un modo semplicemente per stare insieme. Poi tanto anche mangiando gli arrosticini o altro si finisce sempre per parlare di tecnologia, di AI o Python o quello che si vuole. E non è vero, in realtà poi oltre a mangiare abbiamo fatto anche dei workshop, abbiamo agganciato un po' l'università, ci siamo agganciati al GDG di Pescara che, essendo una piccola città, è l'unica altra community che esiste, abbiamo fatto delle attività insieme, noi siamo andati a fare dei workshop, per esempio Django Girls, durante una Dev Fest, e abbiamo fatto attività insieme, abbiamo anche invitato persone da fuori, è venuto Matteo come speaker dalle Marche a Pescara, abbiamo avuto Valentino Gagliardi, abbiamo in programma di ospitare altri, in realtà è un'idea di tutta la community italiana di provare a fare degli scambi e poi magari ve ne parlerà pure Salvatore a Catania, c'è stato qualcuno che è andato a fare visita e l'idea è un po' quello di creare commistioni, quindi ogni piccola community, come sentite, fa delle piccole prove, è un laboratorio in continuazione di fare esperimenti per poi passare le idee agli altri, stiamo cercando di fare tutto ciò. E vi consiglio, da noi è andata così, abbiamo fatto il primo Django Course e i coach che sono venuti a fare il workshop erano ovviamente sviluppatori Python che non si conoscevano e abbiamo deciso di iniziare a fare le PyBeers. Quindi potrebbe essere un'idea, se non conoscete altri sviluppatori Python nel vostro paese, nella vostra città, provate a organizzare qualcosa di piccolo, una birra, un Django Course, qualcosa del genere e poi magari partite. E direi che proprio quando siamo partiti ho ricevuto un messaggio da una persona che non conoscevo, di Catania, che adesso è qui, che mi chiedeva come eravamo partiti e gli ho detto guarda noi facciamo semplicemente delle birre.
Ed è stato un ottimo consiglio.
Esatto, e quindi passo la parola.
Grazie Paolo. Salve a tutti, io sono Salvatore, e come potete chiamarmi Salvo. Anche noi siamo nati relativamente da poco, no? Dopo il PyCon 2023, ecco, ho sentito questa chiamata a fondare, io sviluppo in Python ormai da tanti anni e con i colleghi ho detto proviamo anche noi a fare questo gruppo. Sinceramente non mi aspettavo tutta questa partecipazione, invece dalla prima volta che anche noi attraverso una cena, una pizza in realtà di fronte al mare di Catania è partito tutto. Pian piano siamo riusciti a fare diversi incontri, più nella forma di talk ogni volta, e di volta in volta si aggiungevano nuovi ragazzi, nuovi sviluppatori, nuovi professionisti. Riusciamo a incontrarci più o meno in media una volta ogni 2 mesi, e la formula è sempre la stessa, no? In qualche modo si fanno i talk e poi dopo si va a mangiare qualcosa insieme, ma soprattutto si condividono le proprie esperienze. Qui doveva esserci oggi anche Claudio, purtroppo che supporta la community, anche lui. Un'altra esperienza molto interessante è stata la condivisione tra le community, fra le due community più distanti in questo momento, perché Catania proprio è l'ultima nel sud Italia, però anche Milano, no? con Pietro che è venuto da noi a trovarci più di una volta e ha fatto un talk, e questo arricchisce in qualche modo, no? Anche chi ascolta, no? Perché poi tante volte da sviluppatore ti senti solo, no? Magari non puoi partecipare a quelle che sono le esperienze nazionali come questa qui, e quindi avere comunque qualcuno che viene, questo interscambio tra community è qualcosa di interessante. Un altro progetto interessante, vediamo se cambi slide, del Tecnocamp, eccolo qua, che grazie al maestro di mio figlio Freddy Petalia siamo riusciti a fare il primo corso per ragazzi di Python, per ragazzi bambini, quindi stiamo parlando di un'età tra 7 e 12 anni, ed è stata un'esperienza incredibile, perché vedere ritrovarsi così come avevo fatto io ai miei tempi quando ero piccolo, io ho iniziato col Basic, ma oggi far vedere questi ragazzi, farli iniziare col Python è stata sicuramente qualcosa che ha funzionato e che sicuramente insieme a lui al Tecnocamp riproporremo prossimamente.
Grazie. E prima di passare la parola a Gaetano, che concluderà un po' la chiacchierata, ci tenevo a dire che, come avete intuito dalle slide, a parte Bari, ci sono anche altre realtà, purtroppo per motivi di tempo c'è l'Elio di Python Campania con altri che ho visto che aiutano, c'è qualche altra community che magari adesso è un attimo in stato di quiescenza, però stanno per ripartire, c'è Varese sicuramente che fa gli incontri, c'è Python Biella, non mi ricordo se qui c'è qualcuno, però ho visto in giro, e quindi in realtà sta ripartendo Python Firenze, non so se abbiamo una slide, magari la vedrete passando. Quindi in realtà ci sono alcune community che dopo il Covid hanno un po' rallentato l'attività e stanno ripartendo adesso, oppure community che sono nate completamente nulla prima non c'era, per esempio a Pescara non c'era mai stato nulla. E una delle altre community che invece fa un sacco di attività.
Sì, vabbè, c'è anche Python Roma, ci sono slide che sta ripartendo
ecco qua,
anche lei,
sì.
anche con
Giuna,
Egon che è qui
che
con
non
noi.
vedo.
E niente, io sono in rappresentanza di PyBari, noi siamo nati praticamente quasi 2 anni fa, quindi stiamo per festeggiare i 2 anni, e siamo nati qui perché praticamente non ci conoscevamo, e tramite il presidente di Python Italia ci siamo conosciuti perché ci è stato detto che non eravamo gli unici appunto a voler fondare una community nella nostra città. E quindi siamo partiti così, ovviamente anche noi su Consiglio di Milano. Abbiamo iniziato semplicemente con una birra e abbiamo visto che già lì c'era una buona presenza, quindi il nostro territorio sta crescendo a livello tecnico e tecnologico e quindi man mano che facevamo birre abbiamo capito che potevamo partire tranquillamente con degli eventi, dei talk e abbiamo deciso praticamente di essere itineranti, quindi stiamo cercando di far sì che vengano conosciute le aziende del territorio e ci sia quindi una commistione, quindi ci sia una domanda, cioè nel senso che i ragazzi che vengono da noi abbiano la possibilità di conoscere quelle che sono le aziende del territorio e viceversa ovviamente. In questa maniera riusciamo ad alimentare appunto la presenza all'interno dei nostri eventi e siamo arrivati a 500 follower su Meetup e a 300 follower quasi, se non ricordo male, su Telegram. Stiamo facendo praticamente un evento al mese, quando non riusciamo a organizzarlo per bene andiamo con una birra ovviamente. E stiamo facendo anche un po' di eventi con altre community locali, che sono quelle che vedete qui, e se torni alla slide precedente potete vedere anche che ne abbiamo fatta una al mare l'estate scorsa per festeggiare il nostro primo anno ed è stata un'esperienza incredibile perché diciamo che ci siamo fatti anche un bagno e
Python Chicago non può fare questo tipo di esperienza solo a Bari.
in realtà non ce lo siamo fatti il bagno, però eravamo lì che potevamo farlo,
Vabbè,
però
per il secondo
l'atmosfera era
anno, per
incredibile.
il secondo anno dovete farlo.
Assolutamente sì. E anche noi abbiamo organizzato un data beer, ne faremo un altro il mese prossimo. E niente, fammi vedere un'altra slide che non mi ricordo ancora.
Ah, la prima.
Ok. Vabbè, niente, questo è quanto. Vi ho detto che siamo itineranti.
Ok. Prima di ripassare la parola a Gaetano per concludere con un invito per tutti voi, ci tengo anche a sottolineare che tante volte nelle comunità locali ci sono delle persone che non vi aspettate, che magari vivono lì intorno, sono bravi esperti, magari non si muovono troppo, per esempio a Catania hanno agganciato Salvatore San Filippo di Redis, che è lì vicino, anche a Pescara ci sono parecchi che stranamente si sono trasferiti dall'estero e sono persone in gamba, abbiamo Caleb che non vedo, ci sono tante altre persone che magari incontrate solo se andate in questi meetup locali perché molti magari non si vogliono spostare, oltre a incontrarli qui, però a PyCon Italia è bellissimo farlo una volta l'anno. Nelle comunità locali invece c'è l'opportunità ogni mese solitamente di incontrare persone semplici o persone appassionate che stanno iniziando. E proprio per invitarvi a anche voi fare qualcosa, coinvolgervi, Gaetano voleva...
Sì, diciamo che oltre ai vari eventi abbiamo anche fatto un'intervista pythonista appunto sia qualche mese fa in cui ci siamo detti un po' come stava andando l'anno che qualche giorno fa per pubblicizzare appunto diciamo il dietro le quinte di Python Italia e qui per esempio eravamo un po' tutte le community, ci siamo detti più o meno tutto riguardo cosa fa ogni community locale. Invece per quanto questa slide potete vedere il nostro diciamo, spazio su Notion tramite il quale riusciamo appunto a gestirci perché diciamo che non c'è soltanto community locali che fanno eventi, ma che anche si parlano per riuscire a darsi consigli e a risolvere delle problematiche, ad esempio, che hanno alcune community, o anche semplicemente per darci consigli. E per esempio qui c'è la scaletta per la creazione community o meetup locale che conoscerete se sarete appunto interessati a creare una community da soli o spero con qualcun altro. E quindi qui da questo QR code potete appunto inserire i vostri dati per far sì che possiate creare una nuova community o se volete appunto essere degli speaker, non solo nella vostra community locale ma in giro per l'Italia, perché l'idea appunto è quella di far sì che possa esserci magari qualche venue interessato magari a qualche argomento che tipo il quantum computing che in questo momento sta andando per la maggiore a Torino e quindi ci sia anche una commistione basata appunto sui contenuti perché la qualità è importante insomma. Nient'altro, quindi vi invito a seguirci, vi invito a compilare i nostri form. Se non ce n'è una di community locale, a farne una, ragazzi, perché è un'esperienza incredibile.
Confermo, ringraziando tutti quanti quelli che sono venuti, anche voi, stranamente stiamo finendo in tempo, e vi invito voi, ma magari siete già interessati, oppure chi vi chiede qualche consiglio, no? Noi abbiamo il boot, qui il banchetto delle community locali con la cartina per segnare, tracciare persone a venire lì e parlare con noi, chi si trova lì in quel momento, oppure a chi vi chiede consigli, suggerimenti di venire a trovarci, perché come diceva Gaetano, alcune community sono nate così. Qui a PyCon Italia, Python Italia è l'associazione che ci raccoglie tutti e ci dà una mano insieme, quindi anche se avete paura di trovare un luogo, uno speaker, un aggancio, venendo a parlarci sicuramente troveremo tante connessioni, tante opportunità. Ci sono anche altre community che stanno nascendo un po' collegate, c'è PyData Roma Capitale, giusto? E ci sono altre che stanno nascendo da quello che so anche in Veneto, altre parti, e quindi sarebbe ottimo agganciarsi a queste comunità che nascono e soprattutto se state in giro per l'Italia a visitare qualche città sappiate che magari la sera potete andare a trovare Salvatore e mangiare un arancino oppure,
Siete benvenuti, siete benvenuti.
oppure in qualsiasi altra città per visitare qualcuno a volte, o magari a volte in trasferta per lavoro, può succedere. E quindi vi ringrazio, non so se qualcuno voleva aggiungere un'ultima parola oppure abbiamo 30 secondi o ci possiamo salutare. Adesso con chi fa parte di qualche community che è qui andiamo a fare una foto davanti al tabellone Python tutti insieme, se Alessandro prima si era perso la notifica e adesso c'è. Quindi vi aspettiamo tutti lì per fare una foto insieme e grazie di nuovo. Ci siamo dimenticati.
I think we can start. Welcome everybody, and welcome to our speaker Stephanie, who is a software engineer at Bloomberg, and she's going to talk about the Datamorph package. Floor is yours, and questions on Slido, please. Thanks.
So thank you. As mentioned, I'm going to be telling you about a package of mine, a project called Datamorph, and particularly why you have to be very careful when you're using summary statistics. So we'll skip over most of the bio. I do want to highlight that I brought a copy of my book to give out. I have only one, but it's free, so if you want it, come up afterwards, and I'm happy to sign it for you as well. Okay, so summary statistics aren't enough to describe your data. Let's take a look at an example. So if we look at these 3 data sets, I think we can all agree that they are very different, right? But the thing is that if we had just looked at the summary statistics, they're all exactly the same. So we would not have been able to tell if those 5 summary statistics described the Python logo, if they described those slanted lines, the heart, or an infinite number of other shapes that we could make with those points, right? So the means in X and Y are the same, the standard deviations in X and Y are the same, and the Pearson correlation coefficient is exactly the same. So the summary statistics are only summarizing part of our distribution. So one thing we can do to get more information that will help us distinguish between things is to use what are called moments. So the first moment is going to be the mean, which we know is the same. The second moment is the variance, which again is the same because we saw that the standard deviation was the same. But once we move to the third moment in these cases, which is the skewness of the distribution, we now start seeing differences in those distributions. And sometimes we have to go to the 4th moment, the 5th moment, the 6th moment to start seeing differences. And you can keep going on those, but we're not going to talk about beyond the 4th. So to understand what those particular ones, the 3rd and the 4th, are, I've added the marginal distribution, so the histograms you see for X and Y. So the 3rd moment is the skewness of the distribution. So that measures the asymmetry. So for example, this one over here, you can see the mouse, this one over here is large negative skew, right? And so if we look, negative value is very large here. So this tells apart from, for example, this one. And then the 4th moment is the kurtosis of the distribution, and that is a measure of the weight in the tails. So for example, something like this has less weight in the tails versus something like this has more weight. But now the problem is that we're only looking at X or only looking at Y, right? And that is why we use the Pearson correlation coefficient for 1. But that one is also particularly sneaky, right? Typically, you would just calculate the correlation and move on. But the thing is that the Pearson correlation coefficient, the default correlation coefficient you get, is for linear correlation. So if you don't actually plot it, you could be making a very, very erroneous assumption about linearity. And to illustrate that, I want to bring you back in time to 1973, where this is Anscombe's quartet. So these points were constructed by hand. And again, same properties hold, right? So here is particularly dangerous because the Pearson correlation coefficient here indicates that there's a strong positive correlation. It's telling us that this data set is linear and there's a strong correlation with X and Y. And this is only true in data sets 1 and 3, right? 2 and 4 are not linear at all, right? So again, just looking at those summary statistics gives you the completely wrong idea of what your data actually is. And 1973, people still do this today. So clearly we haven't solved this problem, right? And I'm not saying I've solved it either, but I'm hoping I'm moving forward to having less people fall into this trap. Right, so it's clear that visualization is an essential part of any analysis. We see that. I think we're all convinced that we absolutely need to visualize. Maybe we still don't always do it, right? So in 2020, there was an interesting paper published called "A Hypothesis is a Liability." And the researchers argued that simply approaching a data set with a hypothesis in mind that you want to test may actually limit how thoroughly you explore that data set. So let's look at the experiment that they did. So they took students in a statistical data analysis class, and they split them into 2 groups. They were both given the exact same data set, but one group was just told, explore the data, report back what you find, and the other group was given the data and these 3 tests on the screen that you see. So taking the values in the data and performing statistical tests on them. Like, was there a significant difference in the mean between the two groups? Was there a significant correlation coefficient between two values? So that's all using those summary statistics we just saw. This was the data set. So it's clearly not real data, right? It's shaped like a gorilla. But the interesting thing is that the students who were told to just test those hypotheses were actually 5 times less likely to realize that it was a gorilla, right? Because they didn't bother to visualize it. They're like, I'm supposed to test these, so I'm just going to go and test them. The ones who had to explore had to visualize. They didn't know how to get started. So how do we encourage those students, right, and also practitioners, this is not just a problem among students, to be more thorough in the analysis, right, to make sure that you're visualizing the data and not just relying on those summary statistics? So one way, and I think that this is not just me, but in general where this has moved, is trying to create more memorable teaching aids. I've talked to many people, and they actually haven't even heard of Anscombe's quartet, which kind of surprised me, because that's like the typical example that you see in a statistics course. But in 2017, researchers at Autodesk decided to build upon that and try to create a more memorable example. And this is called the Datasaurus dozen. So they took this dinosaur up at the top, called the Datasaurus, and they used an algorithm, which I'll talk about later, to create these 12 shapes that, again, share the same summary statistics, right? This is already a lot more memorable than just a bunch of points. We now have a dinosaur, right? Not that your data would be a dinosaur, but still, it has more of an impact. And another thing that they did was they added animation. So not just showing you that there's the dinosaur and there's the circle, but showing you that converting the dinosaur into the circle, that every arrangement of points that you encounter along the way to do so, that you are also preserving those summary statistics. And these points are moved randomly, right? So infinite number of distributions of the points will give you this. So those summary statistics are absolutely telling you absolutely nothing, right? It has to be used in context with something, not on its own. And then this, in my opinion, led to another problem, right? So what is so special about that Datasaurus? And in fact, if you look at posts online where people first discover this, they're in awe. Wow, that dinosaur was perfectly constructed to allow this to happen. Maybe it's because they conflate Anscombe's quartet, which was precisely calculated by hand to do something. The dinosaur is not. It's just a drawing, right? And so this was part of why I wanted to build Datamorph, right? Repetition is key, and seeing something different is more of an impact. It's not just the dinosaur. It's not just Anscombe's quartet. It can be any shape that does this. So Datamorph is an educational tool, right? It builds upon the previous research, but it's actually an installable Python package. So you don't need to hack at the research code base like I did, and I'll tell you more about that experience later. You get those animated results right out of the box. It's also possible to use additional data sets. So not just the dinosaur. You want to draw your school's logo, you can do that and then use a CSV. I have also other built-ins, which I'll show you later. But again, not limited to just the dinosaur. And you can also experiment with your own target shapes. So we saw the 12 that they created from the dinosaur. And I've, along with some people who've contributed sprints, added some more shapes. So I think we have, we'll see later, I think it's about 20 shapes that you can convert into. Right? And so again, this makes it more memorable because people have more and more things that they create, and it almost becomes a little like an art project mixed with statistics. Right? So again, that number of examples that you can generate, the number of things you can play with now is no longer limited. So this is Datamorph. So you can see I'm turning the Python logo into a heart because we all love Python here. And again, summary statistics are being preserved. And you might also notice that the values itself here are also completely different to what we had before, right? So it doesn't matter where in the 2D plane it is, the scale, whatever, it can work for this. So let's walk through how this actually happens. Right? So at a very basic level, what I did to generate that example is I simply installed it from PyPI, and then I ran the execute of the entry point that gets created when you do that, and just used the built-in Python data set, and then the heart shape. So this is, again, higher level of what it looks like under that hood. And now we'll walk through each of those steps so you can see how this works. So first thing we have to do is we have to get our data set. So there's a data loader class, and you can specify either the built-in data set, which is Python, or some CSV if you want to use that. Now, a data set is not just a data frame. So the initial algorithm that the researchers had just took a data frame. And that already limits you significantly in what you can do, because that means you're hard coding what each shape means. So it basically is like, if you're doing a dinosaur, then you're doing a circle, and it's exactly at this, centered around this point. So to make it work for anything, to make it work for arbitrary values, there needs to be extra information on top. So I created the dataset class, which is, it holds the data, but it also has 3 sets of bounds. So the innermost bound, this one here, is like the tightest box you can place around the data. So it's the min, max in each direction. Then the red one, the middle one, are the morph bounds. And this tells the algorithm how far it's allowed to push the points outwards. Right? You don't want them going completely away, because then you're never going to get to your shape. And then the final one are the plot bounds. So the way the animations work are by sampling the animation, or sampling through the iterations as you're going through the algorithm, and kind of taking a snapshot of the image. So in order to not have like things shaking around as far as like the axis and stuff, you have a constant frame of reference. And since we're not moving points out of the morph bounds, we know that the points won't get outside of the outer bounds either. So this keeps it a constant frame. And again, that's the key to allowing this to work for arbitrary data sets. So this is what's currently built in the latest release. So we have the dinosaur, we have the gorilla, which was from the other research, right? But there's also a lot of other shapes that you can play with. And the panda was the original, which I'll talk about in a little bit. So once we have that data set, then we need to make the shape, which is going to be what it's going to be turned into. So in Datamorph, there's a shape factory class. And once you initialize it with a data set, you can then make any of the shapes, because the shapes need the data set to be created, so that's just passed in. And we're generating a heart. So shapes use the data set. They all can use it in a different way, but they're using information that the data set has, whether it's the bounds, whether it's the limits in either direction. And you can see, if you look, compare the column-wise, right? The heart is shaped, is drawn on top of these data sets differently, right? The Python logo is very symmetric. So we see kind of the heart covers the whole thing. But the music data set is more tall than it is wide, right? So we don't stretch the heart and elongate it. It stays with its proportions. And a fun fact about the heart is that is actually a trigonometric equation. So you can do lots of very interesting things with trigonometry for these shapes. Yeah, and so each of these, again, is just using the data set to figure out where it's going. So I picked these two as an example because you can see the Python logo has negative y values, and the music is strictly positive, and yet they are both placed on top of it correctly. So currently available, I have all these shapes. So you can see that there's, I think, 8 or so more than what was in the original research. And again, lots of trigonometry and equations goes into this, like the spiral, the figure 8. The spade is kind of just, you take the heart, you invert it, and then you have to figure out how to do the bottom piece. And some of these shapes did come from doing sprints at some other conferences last year. So it's fun to play around with these. And this, if you're using it in the classroom, is also a great mathematical use for it. Like try to figure out how you would calculate a shape that would work for different data sets coming in. So a little bit about how the shapes actually work. So in the original research, it was a giant if-else statement. So basically, if you're starting with a dinosaur and you want to make the circle, at each iteration, let's define the circle as a point at this center point and then a radius around it, right? And then for every single shape, and that is just, monstrous to try to work with. So the first thing I did was to create a shape class hierarchy. So when you think about it, a shape needs to be able to do a few things, right? It needs to be able to take in a point and tell the algorithm how far that point is away from that shape, right? And it also needs to be able to plot for visuals. And so once you have that shape, then things kind of come into groups. So you think about the heart was a collection of points. The spade, again, a collection of points. The star is a collection of lines. So all of these shapes can have a parent class, so like line collection and point collection, that just defines, given a point, what is its distance going to be? And that's going to be the min distance to any line or the min distance to any point, right? So if someone wants to contribute a new shape and it's made up of lines or made up of points, this then becomes extremely easy because all you have to do is define the init method. Like, given the data set, where do I place this shape? And the rest of it is already handled. And again, very, very different from what the original code looks like. So now that we have the data set and the shape, the final thing is to actually perform the morphing algorithm. So in this, there's a Datamorpher class. We instantiate it with like how many decimals we want to preserve the statistics to. And then we would just run the morphing algorithm on the data set to the target shape. So the algorithm is simulated annealing. This is a randomized optimization algorithm. So we take a point at random, and that's when you see it blue. And then it gets moved a small random amount to another spot. That's where you see it red, but only if it can preserve the summary statistics. And this is largely from the code base. I didn't mess with this too much. This is an algorithm, so you really can't change the entire thing of how it works. That's simulated annealing. One interesting thing about simulated annealing is that, again, it's randomized, right? So you need to have a way of avoid getting stuck in a local optima. And one of the ways that this is done is that every once in a while, you'll notice, and these are all iterations where this happens, the point actually moves away from the target shape, right? So we still preserve the summary statistics. That has to be done no matter what. But we do sometimes allow the points to go away from the heart. But the likelihood that we do this decreases over time. And this is called the temperature of the simulated annealing. Simulated annealing comes from like annealing with like blacksmith, and so that's why the temperature is involved. It's like, but you can see here that regardless of how many iterations we run for, the temperature decays over the full process. One thing that I did add to this algorithm is that I think it's visually more appealing when the movement of the points goes at different speeds. So you can see initially the points seem to move very fast away from the Python shape, and then they start slowing down as they get towards the end of the animation with the heart. And that's a very similar process to with the temperature. But the difference is that we cannot decay this to 0, because if we did, then we've had maybe 10,000, 20,000, 50,000 iterations of absolutely nothing happening, right? We need to be able to move the points. Okay. So let's talk about the limitations of this and areas for future work. So one thing I like to call bald spots is a big thing, and maybe you didn't fully notice this in some of the examples, but maybe when I described this, you had the image of what's on the left, right? So you have the dinosaur, and then you have this perfect heart filled out. But what actually happens is you get these spots where no points have gone, like right over here, and then you have clumps where there's large congregations of points, right? So the default algorithm is not really penalizing the points for having too many too close together. So you need some kind of repelling force to account for that, and that's not in there yet. The other thing is the direction of the morphing, right? So I mentioned before we start with the data set, then from that we make the shape, and then from that we morph. So we're morphing from data set to shape. But it would be interesting to be able to morph, for example, from data set to turn the dinosaur into a panda, right? Or to do shape to shape, so turning the heart into a diamond, right? And the challenge is that if one is used to shape the other, and then you have two things that rely on something else, that does, how do you actually size them and move them? And the bald spot problem will also come into play. So speed is also another thing. Right now, I did add some multiprocessing, but it's still, like, if each morph that you try to do, right, you're still going to have to take the time to go one by one. It's an iterative process. You're looping over. Some ideas might be to like take multiple points at a time, maybe try to move 100 or something. But then that changes kind of the whole algorithm. So it does get a little challenging to figure out how to speed up that part. Another thing, which again maybe you probably wouldn't have noticed, but the scale of the data actually affects the morphing time because of the small random amounts that they're moved, right? So the dinosaur in the middle takes about 50,000 iterations, and that's the actual size. If we scale it to half size, it's about 25,000. And double size, it's 77,500, right? So Datamorph already has a way for you to quickly on the command line just scale it down to make it work. But if you're like really wanted to use those numbers that you had, maybe you're in like 10,000s, then it becomes more challenging. You will be there for a while. Another thing is convergence, right? Because you have to set, I want to run this for 100,000 iterations, you might get to the end of the 100,000 iterations, look at what you generated and realize, oh, it needs another 100,000. It didn't quite get there. And then you have to run it again from the beginning. And conversely, maybe you scaled your data down and you wanted to ran for 100,000 and then you realize, oh, it actually finished halfway through. So again, you have to run it again. So having some sort of early stopping criteria and some sort of test for convergence would be something I want to add as well. So a little bit about how this process went, turning this into a package and what I learned from it. So I initially did this because I have a pandas workshop, and in the section for the visualization, I had an image of a panda, I think, and it suddenly disappeared from the internet and I needed something else. And then this crazy idea was born, like, oh, I can turn a panda into something else. That would be a very good example on talking about summary statistics. And I had known about the data source dozen, so I found the code, and I was like, okay, first, let me just repeat this code, like get this to work with their example. And that turned out to be incredibly hard, even though the code was technically there, right? Because there was mostly no documentation anywhere. The code base that they had wasn't even the full code base that they used. They just kind of tried to clean it up, like, let's not look too bad, put this all up there. And then everything was generically named. There's like no documentation of what things did. And you're kind of reverse engineering, what are these magic numbers? Oh, is that actually the mean of this data set? Oh, okay, so doing kind of that. And it took 4 hours to get that. And then I wanted to get this to work for a panda data set, right? So again, I had kind of the similar problems in decoding what those hard-coded values actually meant. And this took me nearly 2 days to get this to work, right? And I had actually shaped the panda data set to have very close summary statistics to the dinosaur, and I still had this much level of trouble with it. But once I got it to work, I was like, wow, this is actually going to be a really cool teaching tool. And so that's why I set about making it a package. And I had significantly more challenges at this point, right? Because now I had to pay back all the technical debt that the researchers had incurred, right? So getting rid of all that unused variables, functions, turning that giant if-else thing into all the shapes I told you about, going from no documentation to being fully documented. I ended up writing a pre-commit hook for NumPyDoc style doc strings, and that actually led to me becoming a maintainer at NumPyDoc. I had to figure out how to build and host documentation in public, right, not through work. How to build a test suite entirely from scratch, and I think I rewrote it 2 or 3 times. How to publish to PyPI and the Conda Forge, which is even more challenging. And then how do you automate workflows with GitHub Actions? So I learned a tremendous amount doing it. And if you ever have like a project that you're even just for you, I would recommend going through all of this because you do learn a lot. And this took 2 months. Largely because I was going to go on a podcast and I wanted to talk about it. If it were not for that, it may have been 4 months. So it was a whirlwind to get that done. And just a side note, I think technically when you're going into uncharted waters, you have this tendency, and this is the right tendency, to think, oh, I'm doing something wrong. Like I'm not understanding something in the docs. But there were at least these 2 occasions where I saw something, this isn't working. I don't think I'm doing something wrong. I've ruled that out. And it is actually an issue with the docs, and so then I fixed those. So, and with that, I have some resources that I found helpful going through this process. And the slides are on my website, so you can click through these later. So in closing, right, so summary statistics are not enough to describe your data. I think we all can agree on that now. Visualization is essential. But also a single plot is not enough, right? Just using the histogram does not tell you as much as seeing the scatter plot with the marginals, right? So if you want to try out Datamorph, I have up there how you can install from PyPI and Conda Forge. There's also the links to the docs, the repo, and if you are a teacher or some kind of tutor or whatever, classroom activities, ideas for that are up there. And I'd love to hear how you use it or any feedback. References to the papers I mentioned. And thank you. So the left is the QR code if you want to send me some feedback, and on the right is how you can connect with me and follow my work. Thank you.
Great talk. Thank you so much. We have a couple of questions on slide, and we have time on Slido, sorry. So we have a couple of questions regarding what's the maximum number of summary statistics that you can fix, and if you can choose which one to fix and which one you can
That's a great question, because that's actually something I was playing around with recently. I just added the median, and you can hold it, but you can actually see the difference of adding the median in. So like if we looked at the Python to the heart, when you add the median, right where the heart comes down, there ends up being a little line right here where it can't push them further. Because you're constraining the optimization even more by adding more summary statistics. But I do want to do something where you can pick a certain amount, but that's probably way down. I will admit I don't have a ton of time to work on this, but if someone wants to do that, I would be more than happy to take a look at a PR.
Great, thanks. And the other two are about what usage you see for this package other than education purposes or for business or, I don't know, research maybe or something.
I think it's mainly for education purposes. Perhaps when maybe we can try a different algorithm, it might be interesting to share kind of that, but mainly for education purposes.
Okay, let me see if we have something else. This is not, okay. There's a question, does this still hold for third and fourth moments? I don't know what's referring to.
So I think maybe it's, because we showed how the third and fourth moment, there were differences. So right now, we're holding the 5 summary statistics, the means, the standard deviation, the correlation coefficient, and you can optionally hold the median, but right now there's nothing in the code that says hold this, or even have the option to hold this. But again, that could be something that you could test and play around with. Like I said, I wasn't sure how the median would behave, right? I had imagined it would restrict it more, but the more things you add, if you tried to hold 20 things, right, then it's going to become extremely hard, right? And you probably have to take many, many more tries to, can I move here? Nope, here, no, no, no. And you might have issues getting stuck, but I haven't tried it.
Great, let's do one more. Have you ever thought about 3D extensions of the package other than 2D?
No, because I really don't have the time for that.
I think so. But could be
I think
one
it also gets
possible
harder
choice.
to, I think maybe if you did it 3D, you could probably get it to work, but I think it almost detracts from it because it's kind of harder to see things moving when they're kind of like behind, I don't know. I feel like there's a reason they've all been in 2D.
True. Okay, we have one more question. How could you use this package like to teach the difference between the mean and the median?
So one of the things I'm working on now is actually running the animation with the marginals on the side. So in the next release, maybe by the end of the year, it'll take a while. But then you'll actually be able to see the histograms jumping up and down. So potentially you could maybe like run the animation without the mean and then one time with the median. Sorry, without the median and then with the median. And maybe you can show the difference on there. I guess that's an idea. But it's not really intending to show you the difference between the summary statistics, right?
Okay, I think we don't have any questions left. So thank you again for the talk. It was very nice. And enjoy your lunch.
And just a couple of announcements before beginning with the speech. So I'm going to remind that we have the Python quiz at 5:12 and the lightning talks at 4:15. And so don't forget to make questions through Slido. And let's start by introducing SPY, Static Python, by Antonio Cuni. Fast as C, Pythonic as Python. Antonio, the stage is yours.
Thank you. Thank you. So, 1 year ago, I was at this conference. I gave the keynote, which is titled. How many of you were in Florence 1 year ago for? Okay, so good half of the room. So it was somehow the prequel to this talk. In that talk, I wanted to describe why, in my opinion, we have fundamental problems in Python about performance and what are the blockers and why Python performance is not as good as it could and should be. There is the link to the talk for the extended version, but the very short version is that Python is very hard to optimize if you are an interpreter or a compiler because everything is dynamic, everything can change at any point in time. Like you can add and remove modules at runtime. You don't know which modules you are going to import until the very last moment. You can monkey patch classes. You can change the dunder class of an object. And for a compiler, it's very, very hard to make sure to implement full semantics and have good performance. There are projects like PyPy. I've been doing PyPy for many, many years. It's probably the best example in this area. It managed to reach very good performance, but with shortcomings because you need a very complex implementation of a JIT compiler. And most importantly, you need to be very, very, to know the internals of the compiler very well in order to get the maximum performance. And it happens very often that you arrive at in a good state with your speed, and then you change a line of code somewhere, and somewhere else everything becomes 10 times lower because the JIT compiler can no longer make assumptions, or the assumptions that it makes are wrong, and that's what I call like performance cliffs. And so it's very hard to reach consistent speed. But at the same time, I mean, that's why Python is a nice language. So if you want a language which is not dynamic, we can just use Java and be happy with that. How many of you would like to do that solution? One, okay. So this was like 1 year ago. Like the talk of today is, I like to think of SPY as kind of a thought experiment. How much dynamicity you can remove from language so that it's easier to make it fast, but at the same time, it's still Pythonic, and we don't end up like Java. I mean, nothing against Java people, really, but it's just an example. So let's see how far we can go. This is also a slide which was in the same talk as 1 year ago. It's just random code, which I don't even know what it does, but like as humans, we know very, very well what it does. Like, we can read it, and we are obviously importing NumPy, and we obviously have a constant which is 10. And we have a function which takes an array and a scalar, and returns a float, because we have type annotations. But the compiler cannot assume any of that, because I could have an import hook which imports something completely different, which is not NumPy. The constant n could be changed by someone else in the program. Type annotation could just lie, because Python type checkers are just not, I mean, they cannot. It's like provable, impossible to make them completely safe. And so as a compiler, you cannot rely on this assumption. But as a human, you do, because nobody will write code which does all the strange things I was saying. So like the idea is to make a language in which what the humans see is what the compiler can, human and compiler kind of agree on what are the rules. I claim that in practice, we already use a subset of Python, because there are a lot of stuff which are super dynamic and part of the language, which you shouldn't use. There are cases, like you can really, I've written code which modified the done class of an object at runtime. And yes, but most of the time you shouldn't. And you shouldn't monkey patch classes unless in very specific situation. And the modern tendency in Python world is that people seem to really like static typing and type checkers because it improves safety. I mean, perceived safety, I would say. And it makes life in IDE easier, but it doesn't help performance at all. So, like Spy, start from here, and let's try to design a new language. I mean, it's a Python variant. It's not something completely different, of course, but some of the ground rules are different enough that you can consider it a new language, but with rules designed to match this kind of behavior which you actually see. The other problem which I want to tackle is that in Python you have this, like, the two-language problem. Like, you have a high-level, nice programming language, which is Python, which is like nice to use, but it's low. And when you want performance, you need to go lower level and change language. You need to write stuff in C, C++. Nowadays, everybody writes stuff in Rust, or use tools like Python, and makes very, very hard to like, you need to know two languages, you need to manage complexity, you need to have like a building tool chain, like it adds a lot of friction. And that's something that also Spy wants to solve. So the goals of my project is that I want something a language which is easy to understand and Pythonic. Like, a lot of the patterns which we like in Python are still doable in Spy, but at the same time, it should be easy to implement. You shouldn't need a PhD to implement a fast Spy compiler. You shouldn't use like state-of-the-art JIT compilation technique, anything like that. Like, right now, I'm working on it alone, and even alone, I can go pretty far. Performance should be predictable, like no longer try to optimize and finger crossing. Like, you should be able to predict and know what is slow and what is fast. And you have one language, and with the same language, you can operate at a low level if you really need a super fast, super high performance. But you can also, like, from this, like low-level core, you can build abstractions which are zero cost or very low cost, so to build a nicer libraries and user experience. An explicit non-goal by design is to be 100% compatible with CPython, because I claim it's not possible to achieve these goals and keep backward compatibility. We tried. I've tried for 20 years, and I don't say that we failed, of course, but I really think that it's not possible. I'm perfectly aware that I'm not the only one in this space. There are a lot of variant / restricted subset of Python / JIT compilers. Everybody has a @JIT decorator nowadays. So yeah, I'm just adding a new one. So from this point of view, I'm not making the situation easier. But from another point of view, I think that Spy actually can help to unify. It's a very ambitious goal. Maybe I will not reach it. But like a lot of these like restricted languages, everybody implements a slightly different restricted version of Python, and which different rules and type systems which are not really compatible with each other. And if you cannot really develop in an interpreter way, because you need to compile them instead to see what is the actual semantics. And Spy can be used as a common front end for all of these. So like Spy takes care of this high-level language, lower it to a restricted core, which is statically typed, and specialized compiler can go from there and well, do their magic. So that's something that, for example, at Anaconda, we aim to do with Numba. So I'm in the same team as them, and the idea is to use Numba as Spy as a front end for Numba, so that you will be able to reuse libraries written in Spy automatically with Numba, and, for example, use the GPU capability of it and things like that. But nothing more, like, Ideally, other specialized compiler can do the same and get a lot of spy features for free. So before going on, I think it's important to underline what is current status, because the basic idea of spy works. You can use spy as a standalone compiler to generate executable, which can be distributed multi-platform. You can compile to native or WebAssembly or mscripten in the browser, but only if you use only spy libraries, let's say. You can build a CPython extension, so you can integrate with the broader Python ecosystem. Right now, it's only in one direction. You can call spy from Python, but not Python from spy. Of course, it will be possible, but later. And I have this kind of low-level core. I can write a simple struct. And I have a super simple, incomplete, half-broken implementation of array, which is not really for general usage, but it's enough to do interesting stuff, as we will see very, very shortly. What doesn't work is that everything else. Spy, at the moment, doesn't have list and dicks, just to understand where we are. But it's on purpose. The idea is that list and dicks will be able, I will implement them in Spy itself, or maybe you, contributions are welcome. So right now, you cannot really use Spy for anything real, but you can use it for something. So this is an interesting demo for those who were yesterday at Fabio's talk about PyScript. So I encourage you to try it, because it's a PyScript application which runs fully in the browser, which also has a kernel of computation written in Spy for speed, and you can just read it on your phone, and I can run it on my computer, and we see what it does. So this is the demo. It does some image processing. By default, it starts by doing computation in Python, pure Python using NumPy. This is the fastest thing which I was able to do with NumPy, so without resorting to any compiled Python. And you see it's very, very slow. It goes to 0 to FPS. And we can, by clicking here, we can switch to Spy. It takes a while just to take the event, the click event, because the slow computation is blocking. And then this is the speed with Spy, 60 FPS, so I don't know, yeah. And while we are at it, I would like to try to do the most complicated selfie ever. So, please, someone take a picture. So, I survived. So this is introduction. That's where we are going and what you can do. The second part of the talk is really a deep dive into the internals. I'm going very technical and very explaining how a lot of the rules and the language works. So the idea is to give you a rough understanding and intuition of how things how I can reach the goal that I was stating before. So the general architecture of the project is that I have an interpreter, which is a super simple ASD-based interpreter. Right now, it's written in Python, so it's super slow because to run a spy program with a spy interpreter, well, you have double interpretation. So it's awfully slow, but for now, I don't care. Eventually, Spy will be able to compile itself. So the interpreter will be compiled to C and to native code, so it will be fast. Then we have some magic, which I'll explain later. And then I also have a compiler. So the same program you can interpret for development's sake and have all the nice features that interpreter gives to you when developing. You can compile, and the general architecture of the compiler is that I take the AST, I generate C code, And then I use a normal C compiler for generating native code. Why this choice? Just because it's very simple. It's the easiest way to generate lower level code. I could totally use different backends. I can imagine having a LLVM backend and then use LLVM toolchain for the specialized optimization if I want. But at this point in time, that's not the kind of speed. Like, once the language is done and functional, I can imagine doing more optimization at very low level. But right now, if we reach the speed of C, I think that we can be happy enough. And generating C code also gives you a lot of interesting opportunities because it makes it very easier to integrate with existing tool chains and tools. So, for example, this is something which I didn't think at the beginning, but I discovered that, okay, since I'm generating C code, it's very, very easy to bind it using CFFI, and then you can get your spy code inside CPython through CFFI. So that's how that's how this demo works, for example. And that's like, it's C compiled to WASM and bind it to PyDide using CFI. So it's kind of super cool that it just works out of the box without too much. So, and before going, like, it's also important that I have both interpreter and compiler, because all the other projects that I mentioned before, one moment. All the other projects which I mentioned before, they suffer of a common problem, which is that you have Python code which run on interpreter, on the CPython interpreter, but then the semantics is different. And I want to avoid this distinction. The idea is that once you have run and tested and developed your program using the Spy interpreter, compilation is just transparent, and semantics should not change at all. I'm running tests, like I have a lot of tests, and thanks to Fabio who showed me how to write a lot of tests. I really take inspiration from him. And each test is run in 3 different modalities, and to check that the semantics is completely the same, including error messages and stuff. So this is the hello world. In Spy, we have exception to the rule, but generally speaking, type annotations are required as in the signature of functions. And then I have a, right now super limited, but eventually can become better, form of type inference inside function bodies. But so at the boundary between functions, you need to annotate your types. And so this is a hello world, something super simple, a print, and I call a function. And let's see. So I can, as I said, I can run it. This is the interpreter, but I can also compile. And this generates a file, which is an elf. And I can, of course, execute it. Nothing special. But, like, for example, I can compile for different targets. So what if I want them scripted? Then this generates a JavaScript file plus a WebAssembly file, so I can run it inside Node or inside the browser. Or I can build for WASI, and then to generate a WASM file, which I can run with WASM time. Or I could also generate the CFFI bindings. In the slides, I also included like the output of what I'm showing, but I think it's nicer and more entertaining to see me typing, and instead of just seeing a lot of. But I include them for like posterity, let's say. So, so we said we have this general architecture in which like you have the interpreter, AST based, you have some magic, and then you have the compiler. What is the magic? So a lot of the logic happens in what I call redshift, which is a form of partial evaluation. So the general idea is, in Python, Python is slow because at every point in time it needs to recompute a lot of logic which is always the same. Imagine if you are having an operation or calling a method, it needs to do the lookup of the method again and again, checking the class, checking whether something has changed, and this is slow. But a lot of the logic in practice doesn't change, so the idea is to have logic same or similar to Python, but in such a way that we can pre-compute as much as possible in advance, so that what remains is something smaller and faster. I use like a color mechanism just for have some vocabulary to talk about it. And the idea is that the blue code is what can be optimized away safely, and the red code is what remains, and it's actually executed at runtime. That's why this step is called redshift, because it takes something which is blue and red and moves, as in astronomy, everything to the red and then removes the blue. Since we are in Bologna, this is not related to football, especially because I'm from Genova and red and blue are the wrong colors of the city. So I want to make sure. Actually, in PyPy, we use same terminology, but it's green and red, but someone pointed out that green and red is not colorblind friendly, so yeah, I decided to switch. The other difference with the slide that we saw before is that, yes, this AST which we feed into the compiler is lowered. So it basically is the same like with lower level operation, which are easier to translate to C. And let's see still our hello world example, which I can show it again. So we have like function to add two numbers and two prints. So I can redshift and we can see this is the result. This is just a pretty print. What is internally is to manipulate the AST, but then I have a pretty printer so that for the end user it's very easy to understand what's going on. And there are a couple of interesting stuff. So for example, the print is specialized by type. And this is something that you can do statically, because since we know the types, then we know that this print statement is always executed with same type, and so we can kind of specialize the version without paying the cost of dispatch at runtime. We also see that everything gets what I call a fully qualified name, and I represent with backticks here. So it's not when I call something, I don't call a generic print function and I need to do lookup. And where is the print function? Could be in the local scope, could be in an outer scope, in a closure, could be in a global, could be a built-ins. Like, this logic exists in Spy. It's just that during Redshift, I do it like in advance, and then I put the result as a fully qualified name so that I don't have to redo the computation again. And you can see that even when I define a function, I define it with a fully qualified name, which exists uniquely in the virtual machine. And the plus, well, this has become like a very low-level specialized function call, which then the C compiler knows to map back to a plus operator in C, but then it's really like a machine operation. It's no longer like this super complex logic that we have in Python. And same for type annotation. Type annotation are evaluated at blue time, so what was int has been pre-evaluated to like built-ins I32. What is blue? Like, the idea is that the more blue stuff we have, the better it is, because we have less stuff to do at runtime. Not a lot to start with. So like literals are blue. Constants are blue. Constant, like I have a constant and I store it in some global variable, and then I promise that I don't modify. It's also considered like a blue data. If I have poor functions which don't have any side effect and don't depend on global state, and they just depend on the parameters or on some other blue global state, well, these are also considered blue. But the escape hatch is that I can also mark functions with this decorator as blue, and then I'm basically promising that it's safe to pre-compute them away. And actually, the rules of the language are designed so that like, you really cannot do anything non-blue inside a blue function. This is an example. I have this function written by ChatGPT. I don't know if it's mathematically correct. I don't care. It's not important. I care if I need to compute a circle, but So this is a function which computes the value of pi, and I have a function to calculate the circumference, and then I have like some code. And what we can do is we can run it. What's the name again? Okay. I hope it's this one. Yes. It works. But if I do redshift, that's when things become so interesting, because we can see that the prints has been specialized, but most importantly here, I no longer have like the call to pi, and also here. And the blue function is completely gone, because I don't need it after the shifting. We will see now how it actually works. So the idea is that like I take the AST, I color all the nodes, and then whatever is blue, I do the computation, and I generate a new AST. And it's easier to just see in graphics what happens. So this is the code. So 2 times call of pi times r. So this is AST. It's a bit small, but I hope it's visible enough. So it's like the standard textbook compiler class in any computer science program. So I have a binom, which is times, and I have 2 operands. This is another multiplication. This is a variable. It's reference to the variable r, and then here I call function pi. And then I start from the bottom, from the leaves of the tree, and I see, for example, that this is a liter, so it's blue. This, it was like name of pi, and then I do name resolution as something which, by design, I can do at blue time. So I walk over all the scopes, and I see that pi is actually a global a function in the global scope, so I can substitute with this fully qualified name constant, which reference module pi. This is like how I spell fully qualified name. And also r, I do resolution, and then I know it's a local variable now. And it's like, this is red, because local variables are always red, unless I make them blue explicitly. And then I walk up. So this node is calling a blue function, so it's blue as well. And now I can pre-compute it, and then that's the magic. Like, the compiler calls the interpreter to do part of the computation. So here, during the shifting, I go back to the interpreter and tell it, okay, please evaluate this and tell me what the result. The result is 314. And then now it's again blue, and I can walk up, and this multiplication is also blue. So I call the interpreter again, and I get the result. And then I walk up, and then I have the last multiplication, which is with 1 blue and 1 red, so it's red. And then the whole expression is basically red, and that's how I get the optimized version. So like we have this interpreter versus compiler duality, and we need both, because you can run things in full interpreter mode, and then like what is the import time, we will see later, it's interpreted. Blue code is interpreted, at runtime is interpreted. And in compiler mode, the first 2 items are still run by interpreter, but what is left after reshifting is compiled and fast, which is what you care about most of the time. The problem is that if you, in a language like Python, like everything is red. That's where we started from. Like, as a compiler, I don't know anything, I give up, goodbye. So what we do is like tweak the semantics here and there, hoping not to remove too many Pythonicity, but having something which is less red and more blue. So the first tweak, and it's probably the most important, is that I codify something which in practice already happens. So in Python, at import time, everything can happen. You can do a lot of magic. You have decorator meta classes. You can do monkey patching. You can generate code, everything. Like in Spy, the idea is that you start from entry point. You resolve all the module of the imports statically, including where they come from. including imports which are kind of inside of a function scope. So all the imports happens ahead of time. This is a big difference compared to Python, but it's not so different than what happens in normal program anyway. And at this point in time, we have basically all power of a fully dynamic language. You can do all the meta-programming that you want, and a lot of this good stuff that happens in Python libraries happens at this level. Imagine SQL alchemy. You are taking a definition of the class, and you are generating a lot of accessors and logic to make it an ORM. This happens, and it should be doable. It will be doable in Spy. Or something like Fast API. It takes annotations and adds all your function to a list of URLs, and this is something which happens at import time. So you like a pattern like that. It's also doable in Spy. But then I declare that you freeze the word, and then all the stuff that you could do before that, they become immutable. So like if you try to modify a class after the freezing point, you get an error. Usually you don't do anyway. And that's the semantic of the language. And then you execute. And in the middle, optionally, you can do reshift. But it's actually like reshifting is kind of just an optimization phase, but the semantic of the language is the same before and after. So let's try and dive deeper inside. So this is like, if you don't look at the blue decorator, like this is pretty standard Python code. Like I have a closure, and I have a function which creates a closure and generates a function to add 5, another to add 7, and I can call it. What if I redshift? Then we can see that what happens is that after a shifting, I really create 2 different copies of the function. One which is add 5, which has this constant built-in, and this other which is add 7, which is constant built-in. So like all the cost of creating a closure and calling a closure is gone. But we can do better, because here in the first example, I passed a constant, but I can pass a type. So that's one way of doing generics. So I decide that I want to have a function to add integers, and then I call makeAdder passing ints, and one make other passing strings, and then I have 2 addition functions specialized for my types. This is generics ugly. And you see that I created, again, 2 versions of the function. This becomes interesting because like this is like integer addition, which is fast, and this knows that to do string addition, you need to call an helper function. And again, cost of dispatch is done at redshifting and not at runtime. This is not a nice way of writing generics, so I have like some kind of syntax sugar. I have this decorator, which is blue, the generic. I don't like this name, I might change it. But basically, this means that instead of calling this function using round parentheses, you call it using square brackets. So like, this is basically calling this blue add function, passing str as the type, and then I have an implementation function which uses this as annotation. Like, it's very dynamic if you think about it, more dynamic that you can do with MyPy or Python type checkers, because they will not be able to understand this logic. In Spy, it just works because the type checker happens later, after this has been executed. So if I do this, I can see that basically that's what we would expect. So like the first calls add of str, and which is this function, and the second call the integer version of it. And of course, I'm not limited to function. That's how I can do types and generic types and containers. And that's how I do arrays, for example. The other tweak that we need to make to the Python semantics is that types needs to be enforced. In Python, type annotation are completely optional and are completely ignored by the interpreter. They're just hints, but the interpreter doesn't care about it. In Spy, you do. So in a case like that, here you are trying to call inc function with a wrong type. If you hit this code path, you get a type error. And note that you get a type error here at this point, not here. Because the type error is when you try to call the function and the type annotation is wrong. But in this case, you don't get an error because as in Python, if you don't hit this line, it's not a problem. So I can, if I use the interpreter, this just works. But I basically have two ways of dealing with errors during the shifting. One is lazy errors, which is what I showed now. So if I do then this call, which was inc of some string, is redshifted into array statement. And this is it's something which is useful, for example, if you are doing some refactoring and you don't want to fix all your code at one time. But actually the default is to have eager type errors. So if I don't do anything, then if the interpreter works, but at the rest shifting I get a type error and it tells me that yes, I cannot call inc here because I got a string and I expect an int and the function, all normal error messages that you would expect from a compiler. And then the final is operator dispatch, because what happens in Python? In Python, when you have, for example, x plus y, it's equivalent to doing operator.add of x and y, which is it's actually more complicated, but let's keep it simple. You check the dynamic type at runtime of x, and then you call $add on it, passing the two types. So that's what happens in Python, and everything happens at runtime. In Spy, it happens something similar, but using the static types. So the semantics is different. So what in Python you get a lot of genericity by just executing stuff at runtime. In Spy you need to actually use generics to do that. But what happens is that the operator dispatch is done in two steps. So I get the static type of x and y, and then I call operator.uppercase add, which returns another function, which is the actual logic. And the function, which is the implementation, is called with the operands. But the idea is that these three lines are blue, so they are completely gone after the shifting, and so what's left is something which is very, very fast. But we still have the power of Python because I can still override and have custom types with overridden operators. And I can totally override the uppercase version of add, get item, or get add, and do stuff based on the static type information that I have. That's one way, for example, of implementing function overloading without paying the cost at runtime. And finally, we have this two levels problem. And what I have so far is the low-level core. So I have a module which is called unsafe, which allows you to deal with low-level memory. And with this, you can, for example, declare a struct, and you can declare pointers. And with that, I can take a pointer to array, to this struct, and construct a higher level type, which is, for example, the super simple implementation of array. And you can see that the dunder new, the important part here is this type lift decorator, which basically it's kind of a cast, but only from the static type checker, the point of view of the static type checker, because the low-level layout of this object is what is in this special dunder LL field. So at runtime, this will be a pointer to array data, and it's equivalent of when you are in C, you have your low-level struct, and then you wrap in a PyObject star, and that's the equivalent, but without leaving the language. And this is, this is more or less the code which I wrote in the demo before. The demo before actually was a 2-dimensional array, but this is kind of same concept. And then this is not something which I implemented yet, but like just to give you an idea of where you can go, like once you have this like uppercase, lowercase distinction, you can do stuff like, okay, I have a done get item of an array, and what is the index? I have this special oparg, which basically represents static information. With you pass things like the static type of the operand, where it was defined. If it's a blue, you know also the value. And you can say something, okay, if I'm doing a get item of a single integer, then I use the specialized implementation just for single integer. Then if I do a get item of a slice, then I can do another specialized implementation for slice. And by composing this, then you remove all the abstraction overhead, and what's left is just the actual computation that you're interested in. And of course, if I call get item on something which is not an int and not a slice, I write type error, and when I write type error inside the blue, then it's, well, it happens what I showed here, and you can get a compile time error or a lazy error depending on what you choose. So that's basically what I said so far. We have the low-level core. The standard library is in progress. I don't have it yet, but it's actually the next thing which I'm going to do. So now I have enough functionality and can start implement built-in types. Contributions are welcome, because that's actually a good point if you are interested in joining the effort, because you don't need to be a compiler expert to do that. You just need to know enough low-level stuff to be able to implement a vector or a dictionary. And that's it. Before finishing, I would like to thank Anaconda, which is my employer, because I'm fully paid for doing this. And I'm 100% on SPY nowadays, so like very good opportunity. You can find me on various social media, and if you are interested in this stuff, I suggest to follow my blog, because every now and then I write updates on it. So that's it.
Thank you very much. No question from Slido, but, oh, okay. So just entered. So you can go. Okay? Okay. It's Tortellini. Oh, wow. I have no question here. So would you mind gathering for it? Thank you very much.
I have 3 questions. I will take not just one. Is type annotation Pythonic, in your opinion? Why we have to force type annotation when we can do type inference and at least reduce the usage of the type annotation?
So, type inference inside a function, I think it's totally Pythonic, because as a human you can follow it. Across functions like whole program type inference, in practice, it's very hard to do correctly. Like my experience is with PyPy. In PyPy, we implemented the interpreter in this restricted subset, which is RPython. And in RPython, we did whole program type inference. And it was a mess, because you have your program which works, and then you modify something in one file, and then you get complete strange errors, because it tells you that this operation is no longer valid, because like the type inference engine is not able to deal with it. Generally speaking, like type inference, it's good when it works, but it's very hard to get good errors, I would say. So I think it's better to keep it simple.
Okay, thanks. I don't want to monopolize.
In addition, is that all the blue code doesn't require type annotation, actually, because it's executed ahead of time anyway. So if you have a problem, you get a real type error. So like it actually makes when I'm using MyPy, I always find hard to deal with these metaprogramming type annotations, because if you have a like classic decorator, which is logger, and it takes a function and logs its argument, what is the type? Well, we don't know, because it generally depends on the type of the. In Spy, this works out of the box, because it takes a function and you can like inspect the annotation and add the annotation of the new function. without the type checker to know, because the type checker will see the concrete function object that you produced. So from this point of view, it's a big improvement over current situation, I think.
Okay, so I got the question from Slido now.
Okay.
We have a couple of questions about the comparison with Mojo. So, for example, given the growing interest in high-performance Python alternatives, what are your thoughts on Mojo as a superset of Python? Do you see it gain a real traction in the industry, or do you think it's more a niche tool for now?
So, disclaimer first, the people of Mojo are super smart, smarter than me, I'm sure they are in good faith, and they try their best. That said, when they say that it's a superset of Python, it's not true. Because superset of Python means that if you take random Python code and expect it to compile, and as far as I know, that's not true. And it's very, very hard to have something which is fully compatible with all the corner cases of Python. So if you are not able to run Django, or NumPy, or PyTest, then you are not a superset of Python. And so Mojo is a variant of Python, which makes different choices than Spy. We kind of play on the same field, but I wouldn't call it a superset.
Okay, thank you very much. No more questions. Thank you again, and thank you, everybody. back in this track with the upcoming talk by Christian, we'll be understanding Python from the inside, C concept, to dive into CPython fearless. So Christian, the stage is yours. Don't forget to put your question on Slido.
Thank you. Can you hear me well? Yeah, I think that you can hear me well. Good. So my name is Christian. I like Python, like you all, I hope. But I also embrace the idea of liking other languages. How many C programmers do we have in the room today? Can you raise your hand? C programmers, actively C programmers. Yeah, I knew. Okay. So this talk is an advanced talk, as you saw in the program. And the reason of that is because every time that I was putting these talks into intermediate, a lot of Python developers would arrive in here without any knowledge of C, and they were very scared about the things that I was explaining. But don't worry, at least all the material will be online afterwards. I will share it on Discord, so you can reproduce the examples and everything and try it out yourself. So if you want to connect with me, ask me any question, that's my social media or my website. You can find me there, whatever. So I started with the talks on this topic because I had the feeling that every time that you were mentioning Python internals, people got scared. They thought there was a very obscure thing that nobody understood, so it was very difficult to understand, right? So with that, the motivation of this talk, as I said, is twofold. The first one is for you to understand how things work. I am personally very inclined into trying to understand how a system works. Like, I'm pretty sure many people here, when you were a kid, you were like destroying some toys and see how things were working inside. Because I have the feeling that this is very useful for you to understand the actual thing you're using. But the second one is to lower the barrier. I just want you all not to be afraid of Python internals, just to understand a little bit better, and maybe having enough tools to try it yourself. So most of you, as I said, usually treat Python as a black box or something that you don't know what is in the middle, something does, but the only thing you know is that you need to write some Python, right? So because it's an advanced talk, I want to see what is the audience level currently. So don't worry, I will ask you to raise your hands in some part of the talk, but now I would like for you to shout a few things. So who is using Python 3.15 already? No? No package maintainer? Thank you very much, Hugo. So I just compiled this from CPython, and I wanted to try something with you. So okay, let's start easy. Declaring a list. Everything is fine, right? All good? Yes? Okay. How do we add the number 1 to the list? You can shout. Perfect. How can I add an item twice to a list? Right? How can you? You need to read the documentation. Come on, this is Python. It's 3.15 is coming to you all. You need to have this thing in production. How can you add an element to the beginning of a list? You need to just no. That's. It's just a penalty otherwise. So come on. I mean, this is an advanced talk, people. Like I was expecting more. Okay, let's do something easy. So, do you know how to, I don't know, have a loop that iterates over the first 10 numbers and can give you the even numbers? With what? With the range, and then you use the? Which is the loop name? Is a while or is? Yeah, but we're in Italy. So it needs to be the per loop, right? Nell'intervallo. And then we need to check. And then finally we do the stamp, but everyone, of course, not. Right? So this is, of course, if you're in a different country, you need to code in different languages. Okay, so, well, you were not so advanced that I was expecting. I'm sorry, but anyway, let's try to fix that. Now it's completely fine. So before understanding how this thing could happen, we need to understand programming languages in general. I will not take a lot of time for this introduction, but if you go to Wikipedia, maybe you already saw that there's a huge list of languages there. You can get crazy by trying to understand most of them. But I want to focus on the C programming language. I learned how to code in C. I don't know if that was a good thing or bad thing, but it was challenging. I didn't even touch code before, but I learned in C. The long story is that Ken Thompson at some point was trying to write a compiler for Fortran. He said, no, this is too difficult, and decided to use BCPL and then mix it with a little bit of Smalgold and created a language called B. Very original, right? And then Dennis Ritchie came and I said, well, maybe we can improve this thing, add a few types extra, whatever, put some assembly code on top of it, because everyone knows assembly as well. And then they call it the new B language. So they said, maybe, wait, we call it C. And that's the story of C. C is very crucial for everything, right? I mean, if you want to summarize it with one slide, C really runs the world. Everything was writing. I mean, Git, the Linux kernel, Windows-based system, whatever you name it, has some C components, right? So, but we are here talking about Python, not C, yet. Who recognizes this code? Can you raise your hand if you recognize it? I will not ask you, don't worry, I will not put you on the spot. Because we talk about programming languages, we talk about inspiration and evolution of programming language. This is ABC. This is the predecessor of Python that Guido took into it and tried to build Python. So if you see like the for loop in the middle, you kind of like feel the Python in it, right? You have this for whatever in document, so it's very typical. So Python was not like from the suddenly like appearing and popping up from nothing, right? There was a predecessor. So there have always been previous programming languages that you used to fix everything inside, right? So let's talk about the Python implementation there. But there is a detail. Which one? I always like to show this screenshot. Which is the Python you use? Can you recognize it? No? Well, maybe you saw that some of them has the greater than like 5 times or 4 times. Well, I hope this is not new for you, but these are the languages that you have there. So first you have MicroPython, then PyPy, the version written in Python. Very weird, I know. The implementation written in Java, the implementation written in Rust, in C#, and the last one is the vanilla Python of everything that you are using. But it was very difficult to understand, right? So Python is kind of this kind of weird thing. So we will focus on the standard implementation, which is the Python that is written in C, right? So if you go to GitHub and check it out, you see that there is a 35.8% of the Python that is written in C, and this is because most of the building blocks of the Python programming language, the C implementation, are in C. But what about the ecosystem? You have heard a lot about this thing. So if you check out Pydantic, for example, we had a talk the other day, they have 40% Rust, 59% Python. Okay. PyTorch, maybe you're also familiar, they have a huge portion of C++ because Torch is written in C++. Then you have DuckDB, in case you're familiar with this SQL database management system. It has a lot of C++ as well. UV is also might be very popular right now, so a lot of Rust there. So most of the packages that we use on normal days mix many programming languages, right? So that's why I believe that it is still interesting for you to learn or at least to understand the C implementation of Python and try to go deep. But for that, we need to learn a little bit of C. So Python and C, very quickly, I will show you this Python code. Everyone should read it without any issue, I hope. So I tried to force there the print in order to look more similar to the C implementation. You have there roughly an equivalent. It's not exactly the same, so the C purists, please don't worry. I understand that, but it's just similar so you can get an idea. Not very complicated, right? I expect you feel the same thing. And if we add type hints, for example, to Python, I don't know. I mean, if you believe that one is more complicated than the other one can argue, but as you see, the C implementation there is not so critically like complex and everything. So you kind of get an idea. So a few details of the language. I don't want to bore you with this. So in C, well, back then it was a high-level programming languages because you could, not program in assembly. There are not only one int. There are many types depending on the precision and the amount you need. There are, of course, 2 decimal types in case you need single, double precision, which is very related to CPU architecture, but we will not go there. There is also this concept that doesn't exist in Python that you can declare variables without initializing. So in C, you can do like int variable, and then you have the variable declare with an undefined value. You don't need to have a value or a non-type at the beginning because that is initializing the variable. Memory management, which is some of the critical aspect of the unsafe of the language that many people are saying, oh my God, we need to do memory allocation our own self, and many other programming languages are solving like Rust. So in C, it's a bit more complicated. You can create maybe an array of integers at the first line there, or you can do it allocating memory and allow, like item by item, putting them there. Of course, you cannot mix types there because it's, well, you kind of bypass it, but literally you cannot simply with the native data types. And also you need to free the memory. So this is the caveat that people start to say, oh my God, I need to worry all this thing, but it's not so crazy. The structs in C are something that are very similar to a data class. I guess that you're all familiar with data classes, so it shouldn't be so strange to have this thing around. And pointers are also something that might be very tricky for you. I know that we're going a little bit fast, but I want for you to at least to get the general overview, and then you can check that out later on. In a nutshell, pointers for you to understand is that you have a variable, so you have a value associated with something that is in your memory. In that case, the memory address, for example, is 1000, just an example. But there's also this concept of pointers that you can point where something else is. In this case, we're pointing with the other memories. So as you can see there, the value of P is the 1000, which is the memory address of the next variable. Sounds a bit tricky, but I promise you, besides that, it's not so complicated. Let's do a little example. I know you will maybe will be unable to reply, but let's just do it for the sake of things. So if we have a number 42, a variable int, and then we have a pointer pointing to that address, then we know that B also will be 42. Easy, because it's the same as the other example. Then we create a copy of A, and then we do another variable that has the value of the pointer of B. So these are the values that we have currently with the current configuration. Why pointers are seen as difficult is because the arithmetics between them, when changing things, can be complicated if you don't remember all the details of the things you have, where things are pointing, right? So if we do these two small changes, at least you can say that, okay, the pointer B will have now a value of 10, but then you start to think, oh, but wait, B is pointing the reference of A, so it also will change A. And then you are changing C as well. So this is how we ended up thinking. So this is why at least pointer arithmetic, I hope this was not so confusing, but it can be tricky because you need to keep track of where you have your things, the memory allocations, if you have pointers, where they're pointing at. Okay, this is easy one. This is the most simple C program that you can find, of course. If you have to have a hello world kind of thing, you need to write a main. For using printf, you need to do this include, the standard input-output, and then also you need to compile. That's one of the biggest differences as well. You need to compile this language in two ways. You can have the first one kind of like without specifying many things, with GCC in this case, or specify the name of the binary, and you execute it. So yeah, that's it. You learn C, and I'm really proud that now you will be able to understand. But as you see in the bar on the bottom, we are not yet done. So let's look inside. I will not spend a lot of time on this, so we will close our Python 3.15, and we will do something very weird. If you're not familiar with GDB, don't worry about it. It's just something that you use to look inside binaries. So here, I told you that you need to have the main function. So for example, we can do something very simple and try to say, oh, let's break when we find the main function. Okay, we need to download some stuff. There you have it. That's the main function of Python, which is calling another main function called py bytes main. So if we continue, we see that that main function has another main function called pymain main. We can continue here for like 3 times, but I would not like to continue, but at least I would like for you to see that you have started to see some like notions of variables written with py something. So maybe let's do a break with that one. So maybe you can see something else that I wanted to show you. Yes. So you see that there are also some other variables, py status, whatever. So there's like apparently all these variables are py something within the C implementation of Python, right? So I know, as I said, this was very weird and strange. If you have questions about how this thing is there, then ask your nearest core developer so they can reply why there are so many mains there. But that's not my discovery in this talk. So now the idea in the remaining like I have more time, so I'm going to slow down. For you is for us to rediscover Python a little bit through C. Yeah, how the Python works, but okay, we need to correct how CPython works because I will not talk about the other implementations. In a nutshell, this is the most simple approach that you can understand what happens between your Python code and what is being executed. So there's a decoding first, depending on the encoding of the file. There's a tokenization part when you start to split your code into bits. Then you are parsing to try to understand those things that you cut. And there is an AST, an abstract syntax tree. It sounds more complicated than it is. I saw some people join there, so don't worry about it. This is the only slide about this. Then you have this structure of where to resolve in which order, right? And then you have the final compiling step for the virtual machine of Python. So you have a virtual machine that have instruction one by one, right? Simple. Who here likes that now Python is faster? with the faster Python project, right? Well, because of that, because you need to start doing optimization in your code, this is kind of a different now. So in this little step there is a lot of things happening now. There is some optimizations. Now all this bytecode that I told you, there's some, they are split further on in some micro operations, and then when they have all the micro operations, they remove the ones that are very redundant, and then after they remove them, they detect the hot codes sections, and they start, so everything is a bit messy there. But for that, I am not an expert in that topic. I really recommend you for you to watch Brand Butcher talks from PyCon US from last year or this year. Very cool talks, so I totally recommend it. So for the code, I hope that at least you knew that Python is on GitHub. You can find it under Python/CPython, the standard implementation. And inside there are many directories, and I will not go into a lot of details of what do you have to find inside, but the most interesting thing for you to understand is that you do have some splitting between the modules, which is the standard library written in C, the objects, so for example, a list, a dictionary, a tuple, a set, those things are written in C, because we talked already that the building blocks are written in C. And then you have the runtime with everything else, right? So how does the abstraction work? Now we'll start to look into details of the CPython. So if you have some coffee, please sip some coffee now, because that's the part that might become a little bit denser. So everything in Python, well, most of things are encapsulated into a Py object. But you already saw that the struct in C, it's kind of like a data class, so it's something, you need to fill with stuff, right? So Py object, the building block of everything inside C. This is the definition of the object, which sounds or reads very complicated. But in a nutshell, it's only some workarounds, some compatibility things with compilers, because we love to run Python everywhere, but to run Python everywhere, we need to be compatible with many compilers in Mac OS, in Linux, in Windows, and now the new architectures. But for the case of Linux, which is what I am using here, this will be the simplified version after resolving all those things. Pretty simple, right? Yes? The thing is, then you see there that there is another thing called PyType object. Well, this is also a building block of CPython, which is the type information of this object. So it's called optype. You saw a pointer there. Well, that's pointing somewhere when you start to implement it. So I hope you are connecting the dots at least with what we saw before. And if you look inside this, it's a bit overwhelming, right? So this is what is inside this type object structure. But it's a structure full of different cases and things you can use depending on the type you have, because we love to write A equals 2, and then you get an integer, or B equal hello, and then you get a string, right? But to have this kind of like not worrying about declaring the type, you need to have something generic enough in order for you to be able to handle it, right? So you have all those things, but as I said, it looks complicated, but it makes sense. This is the simplest analogy that I could find in order for you to understand this type object or the Py object. If you have this piece of furniture, and you put it in your room, what do you fill it with? Maybe clothes, I don't know, some old hats or whatever. But if you put it in your office, then you will put some office supplies, right? Like, some pens, whatever. The idea of Py object is the same. You fill it with whatever you are using it. So in a nutshell, that's it. If you want to have an integer, you will have a lot of attribute inside that depends on for integers, but the one for strings are not in use, right? So you fill it with whatever you need, and then you manage to have this amazing encapsulated object. So now everyone is thinking that Python is easier, right? Who thinks Python is easier? Don't be afraid. I will not call you out. Don't worry. Okay. So now let's do a little experiment. Who is familiar with this Python code? I will not ask you, don't worry. Just raise your hand if you understand the code. You don't need to say it. Maybe you can say it to the person next to me. Of course, it's a Lambda function. Keep it up. Keep it up. Now, who is familiar with this syntax? This is valid Python code. Oh, there was a overwhelming hands going down. This is just initializing a list of all these letters. Okay, keep it up. Who understands this code? Take your time, read it. Keep your hands up, because we are proud of, I think we have like 5 people remaining in the room. Okay? Who understands this code? Yes, I know, because you know this, and other people. Yeah, this is the Quine, so if you execute the code, check it out after the talk. Who understands this code? Okay. Oh, more hands going up. Oh, good. And this one? Who is brave enough, not you, to shout what this the code does? Or what it does? It's clearly, you can see clearly there, that is checking if a number is a power of 2. I am very disappointed again that you cannot see anything. You can try it out, I'm not lying, but you can try maybe after the talk. And what about this code? No, I'm just kidding. This is Pyth, which is a different Python. It's for code golfing, but if you're interested in this, you can check it out. So all languages can be hard and easy. Please do not use this argument, at least after this talk of, yeah, no, I prefer to use things in Python because everything is so easy. Well, you saw already, things can be complicated. Maybe you will not find that thing too often, but it's possible that you will find maybe your new, I don't know, employee in your company will submit a patch doing these crazy things, and you will need to be able to understand because you're a Python expert, right? We all are, I hope. Here, I'm not, but it's fine. So yeah, as I said, this sounds complicated, but I hope you don't worry, because the C API, in my opinion, the implementation is very, very simple. Inside, you have a lot of functions in C that helps you to navigate all the types that we were looking at. So we talked already, PyObject, a big object that can hold different things, a container with things. But if you want to check and build stuff, for example, there you can transform a C string into a PyObject that will be futurely a string with PyUnicode from string. Then you can get the len function from C with the getLen method as well. For lists, for example, you have that. You can build the same string, create a new list, and append in the value. So you see that, I mean, now you know a few things, so you can understand. But the idea of this C API is to be simple. The same reason that we have this PyObject with many things, we have also very convenient functions to detect, is this a list? Is this a dictionary? Is this a tuple, right? Very simple thing. And even further, which is something that I really love, is that all these functions, I guess many here knows the function glove, because you have using for, of course, not the best, most efficient thing, but you know it. So to list some files, this is the way that you can parse all the arguments of your functions. There are this very amazing function called pyarg, parse, tuple, and keywords. Yeah, long name, but it's very useful. So you can call it already, and automatically it will parse everything you have in your Python function, and it will abstract everything to C. Very convenient. So sound more reasonable, I hope, from all the C abstraction that we were saying before. You have like very ad hoc methods and stuff, so I hope you are more convinced. So for example, we were playing around with the append code before. So if you want to check the append now, the proper implementation is this one in internal CPython. And then you have there's this pylist, append, take, reference kind of thing, which in a nutshell, I know this sounds like, wow, very many things happening, but it's only making sure the size is correct, resizing your lists by 1, and then adding a new item there. The reason that I left this commented code there is because this is how it used to be. Pylist set item makes a lot of sense if you ask me. But with all the things about now no GIL that everyone is so happy about it, this is the way of writing that line of code, because you need to have an atomic operation not to mess up with all the threads happening. So see, we are getting a lot of performance things, which is an amazing thing, but this needs to complicate a bit the implementation. At least it's one line, so that's a good thing. So most of the details of the C API are in the documentation. Please, please, please don't be afraid of checking it out. I know that maybe you will not use it in your everyday, but just go there and check it out, because at some point maybe you will be debugging some Python code for some reason and you end up with CPython code and say, whoa, what is this? You will get an idea of what is happening there. So for talking about the object lifecycle, I prepared only 219 slides, but the idea of this is objects, this PyObject that we talk, they live in this control reference counting kind of like approach. Meaning it's like if you have an object, you use it once, then it's one reference. You use another one, 2 reference. But then you stop using it in one place, you decrease 1, and then when the thing decreases until 0, the object is destroyed. So as I said, if object has no reference, it's garbage collected. That's why we don't need to use. That's why we don't need to use anything like that. Yeah. So you need to increase and decrease the thing accordingly. We will keep the other 218 slides because this is a very dense topic. I know if you start to look inside, there's a lot of details of when to decrease because you need to do some checks and everything. But I just wanted for you to be aware because since before we were talking about this memory allocation and freeing up memory, you need to know more or less like how Python objects are being built or handled out. So is this usable in real life? And the answer is yes. So before we were describing some modules that maybe you know, and for example, I work in a project that is literally exposing some huge code database in C++ to Python. And for that, we need to understand how to create extensions of Python in C. I think that I will use a couple of extra minutes for this explanation, but we will stay in time. So an extension in C can be written. This is the most simple one that I could have. You can check it out later because the code will be in the repo that I will show at the end. This is just a function that has hello, building some string for Python, declaring all the functions of your new module, and then struct, you remember, just a box that we need to fill with some stuff, some detail for creating a module called PyCon it, and then we said, please create a module. Everything using the C API. So what you get from this, when you compile it, is that you can get this module with the function hello, and then you had a string. So this is kind of the easy approach that many people use when you have to optimize a little bit of bottleneck of your code, that you want it to be more efficient and stuff. If you like Rust, in my opinion, I think the developers of PyO3 did a very good job because the API is very simple. Who here programmed in Rust, by the way, is aware of Rust? Okay, cool. Professionally. I knew. Okay, so you can create similar things here, and it's also amazing in Rust. It's not only C and Rust. There are many languages that expose this thing to create modules with Python. So any real project, as I told you before, I work on this project. You maybe don't know it. I will not bore you about it. I promise you this is the only slide that I have, which is moving a huge C++ framework that is older than Python to Python, right? So in case you want to check it, maybe some of you thought PyQt. No, that's a different story. It's PySide. So if you want to check it out, you can do it. But this exactly the same idea. If you really learn everything that I have been telling you here, you are able to really grab any C project or C++ code and try to do it there. But exposing these projects is not very easy. And I show you all these lines of code to just do one method called hello, right? So it's very cumbersome. But you're not alone because there is a lot of tools out there, binding generators like PyO3 that we just saw, that can help you on these things. I will not go into detail. This is a brief summary of C and C++ support binding generators. The one in green there is the one that I work with, so it's compiled with PyPy and CPython. And the one we saw in Rust is PyO3. But maybe you're familiar with PyBind11, CFFFI, or Boost Python even, right? So these things simplify the whole process for you to kind of get this kind of things. So I hope that at least now you have experienced Python differently, hopefully. And you have the tools now at least to keep learning without being afraid. So I hope maybe also you can make the changes that the language needs. And that will be it from my side. So thank you very much for your attention.
So thank you very much. If the phone doesn't trick me this time, we have no question. So maybe I will be going to pick someone.
That's perfect, because if no question, it means that everything was very clear. So I'm really happy about the outcome of my talk.
Maybe we're going to pick someone from the public.
If you're interested on the Italian Python code, by the way, everything will be in the repo. I think that I didn't push the patch there, but it's simpler than you think. So I really hope you can give it a try. And it's open source, so you can use it and do a lightning talk maybe today, tomorrow, or maybe submit a talk to another conference.
Oh, okay, we have a question there. I'm going to... Sorry, can you... Oh, okay.
So thank you for the presentation, first of all. It was very nice. This is maybe more of a curiosity. So you focused on CPython. And there is some debate, as far as I'm aware, on how much the C API should be coupled to CPython and how much it should be implementation agnostic. So what's your thought on this?
Yeah, I mean, my opinion is that there should be something. I also gave a talk about HPy at some point and the stable API. I know this word sounds weird, but bear with me. So yeah, I also believe that, I mean, I don't know if the best solution is to decouple completely, but the problem that we have the C API at the moment, at least the people maintaining modules with C or C++ extension, is that things change, things break, and if you want to use new API, you cannot, as long as you use the stable API. Why this stable API thing is a thing is because I can generate one wheel for Linux from Python 3.6, for example, and it will be compatible forever. That's the stable API. You have seen many projects, for example, NumPy. NumPy does not do that. So you have like wheels for Python 3.7, 3.8, 3.9. So with this approach, you have one wheel, which is, in my opinion, the best approach to have one package to serve everything. But I will try to maybe think that, maybe you have heard about the Wheel Next project. So they are also trying to implement some kind of like better wheeled infrastructure that maybe this could be tied. It's a shame that Hugo left because maybe he will have the answer as a core developer. But I believe that at some point we will need to reach that. Maybe use HPy if people like to jump into it, but I don't know. But now it's very tricky, and I hope that we find a solution, but I don't have an answer for what would be the best.
Yeah, thank you, thank you.
You're welcome.
Okay, so maybe we can pick another one. Okay.
My question is, I've come across the C-types module.
Yes.
And I found it very useful for bringing bringing C libraries to Python. And do you have any downside you would like to share against the other approach, like to build the C
Yeah, I mean,
extension?
C-types is a very simple, and I think that is a very useful way for you to get started on this thing, but you will start to find issues when you want to have deeper control of your structures and objects. So for example, I really don't know if you can with C-type, you can correct me if I'm wrong, but I think that you cannot kind of define the ownership of objects. For example, you have an object in C++ or C, and then I wanted to pass it to Python. Is there a way of saying like this object now belongs to Python, so I don't care about the C implementation, or the other way around? Which sounds complicated, but it's a very usual problem that at least I, as a maintainer, find in the package that I maintain. So all these low-level configuration, for initial things like, oh, I want to optimize this a little bit, a few variables, very good. But when you need to do more advanced things, or let's say you want to build the next PyTorch, I think that C-type will not scale because there are too many details that you need to handle that C-type does not cover. But yeah.
Good. So thank you very much. You can follow up with questions after the talk. Thank you again.
Thank you. I'm glad you liked it.
This gets more cringe. So, a couple of PSAs before we get started so that we let other people come in. Reminder that at 5:30, 17:30, if you are from Italy, in the keynote room, we will have the public quiz with Rodrigo. You get a chance to win some things, but also multiple things, depends on how well you do. Okay, that's how a quiz looks like. Okay, I have to answer questions, etc. I think it will be individual, so you cannot participate in a team. I think this was done to maximize the amount of casualties that we can get. Still, okay, first PSA, second PSA. I got voiced that like the panciotto, il gilet with like shorts isn't really nice, so here we go. I updated my style, okay. Thank you, thank you. I was also feeling a bit hot, so I wanted a scarf, but no one had one, so I had to go back to my roots as a presenter with the plushie. Okay, so welcome everybody to the second session of the lightning talks. Day 2 out of 3. Can we get all the talks done? And why no? We're gonna do that with Alessia, my really faithful companion in this really adventure. Thank you, Alessia. Just a big round of applause for her. Without you, I would be drooling and being distracted all along. Who was here yesterday?
Sure hand.
Oh, okay, you did like that. Thank you very, very much. Okay, so I can go much quicker on the explanation because we have just like, whatever, half an hour in total, and we already wasted like 5 minutes of those already. So, Lightning Talks the Italian way. We want to teach people that come to Italy for the first time how to do things properly in our country. Yesterday we did it with Emilia-Romagna and what comes from there. Remember that Emilia and Romagna are two different things. The same goes for Roma and Lazio, also for Firenze in Out of the Wall, etc., etc. We do it today with pizza, of course, and we hope that you learn how to understand how to behave when you get a pizza. Because in general, this is something that we don't want to do when you hang around. Average reaction to this kind of request ranges from pure like Italianality, okay? Also to be more like a strong reaction that we hope you can avoid. Bear in mind, this is the context, this will become useful later. Lightning Talks. Who's the first Lightning Talks ever? Did anybody attend the Lightning Talk? Show how you appreciate those. Who attended the Lightning Talk already? Oh, come on guys, you need energy, you know how this works. 5 minutes, all topics, all feelings, all experiences. You can share anything that is compliant with the code of conduct that also lasts within 5 minutes. Otherwise, you will be interrupted by our faithful assistant. He came straight from Florence as well, unlike somebody else we know. But nevertheless, he will be there signaling you that the time is done. How does this work? In the pizza box, we have 3 flavors of Post-it notes and sticky notes. The first one is first-time speakers. We do want you to feel safe and encouraged to come up on stage and tell anything you feel about it. We do welcome them, especially if it is the first time for you. General track is anything else, people that have already done one. Event announcement, we're gonna do them shortly after I finish explaining you the rules. Rules which include the menu. As yesterday, we want you to feel the Italianity of this, so we have the pizza, la pala della pizza, which will also be la rotella. Guys, come on, la pala della pizza! Oh. Ma dove siamo? In un RSA, ma insomma, okay, let's go. The pizza menu, if you come on stage, you can, you're not forced to, but you're highly encouraged to entertain our little restaurant game. The game is you spin the wheel, you get a slice of pizza, and magical rules apply to your lightning talk. If you get the vanilla, good yet sublime pizza like Margherita, the original one, what happens when you take it and when you talk, you need to be Italian while you speak, okay? You need to be like, this is not cultural appropriation, okay? This is compliant, okay? You should be waving, you should be enthusiastic about life, you should be concerned, you should guide people towards what's happening with your hands, of course. But not only that. Second round, pizza alla bolognese, like Bologna is typical from here. It's not only the name of this, la mortadella, la mortazza, okay? It's really good. Last time we were in Florence, we had shrimps. Now we have something more local. And what's more local in Bologna than mortadella? One would say tortellini, one would say lasagna, one would say ragu, one would say passatelli, one would say whatever. No, we're not doing any of that. We're doing motor cars and motorbikes. Okay, oh, thank you very much. And so what happens if you pick the pizza con la Bologna? You will ride your flaming Ducati. Okay, so we kind of expect you to be driving around, guiding us on a tour through all of the emotion that you want to share with us within those narrow 5 minutes. Let's do the boring one. We all have to eat our veggies, right? Right? I know there's like fried stuff and all the tigelle and stuff like that in the menu, but still, like, pick one broccoli. If you pick it, we will be playing a game together because veggies are something we all have to do together once. So quick bracket. We will choose one word before you start your lightning talks, and when everybody says, whenever the speaker says that word, everybody will quack. Okay, so for example, if the word is lightning talks and I say, oh, the lightning talks are so awesome. There we go, congratulations. They're really sharp today, okay, they like the game. Finally, we start going to the sector of, maybe not, right? Pizza. Pizza with bacon should be fine, but if you put BBQ sauce on top, that's a big no. Vabbè, okay. You might do that in Berlin, but we don't do it here, okay? Come on, my friend. So, and you will be visually impaired when you do the talk, right? Because this is a clearly syntax error, and we do not accept that in our sauces and on our pizzas. Finally, so the evil pizza, okay? If you spin this, you will only have 3 minutes. We were merciful, okay? You could just skip it for this one. Okay. Remember, be fun, have fun, be nice, be free not to play if you don't want to. So before we get ready, just to get up, I would like all the people that have an announcement for today to come up on stage so that you can share the upcoming PyCon events that are happening in the upcoming, there we go, month, weeks or so.
And while they get ready, I will extract the first general track so you can get ready. Meta-euristica per le reti neurali, Luca Di Vita.
Minchia. Luca? There, okay, getting ready. Okay. People on stage for the event announcement, please come.
You have 1 minute.
Welcome. You can go on, just tap it, yes, it will be already set up for you.
It's a virtual event. It's called Unitary Hack. We are running the 5th edition this year. It started 2 days ago. Runs for 2 weeks. And you can basically go there, register as a participant. There are like 52 open source projects. Each project has like 5, 6 bounties. They are just GitHub issues. You solve them, you get real money. And yeah, it's mostly about the quantum ecosystem, but it's just tasks in Python, in Julia, in Rust. Most of them are actually in Python. As I said, all of that is open source. You can check the website. Yeah, this is funded by a class project.
Thank you.
Hi, everyone. Can you hear me? Yes, so I'm here to advertise EuroSciPy. Who ever been to EuroSciPy before? Okay, it's a European scientific Python community conference. It's happening in Krakow in Poland this year in August 18th to 22nd. 2 days of tutorials, 2 days of talks, 1 day of sprints. Ticket sale is open, and Finite is also open until tomorrow, I believe. So if you want to apply, go to the website euroscipy.org. And we also have maintainers track, and the call for sponsors is also open. And thank you very much, and see you everyone in Krakow.
Ooh. Again.
Hi, yes. I am not an organizer, but I know this is happening again. It's coming back, PyCon UK, so if you're in surrounding areas, please maybe visit. It's in Manchester. They told me it's an amazing city. I have never been, but I recommend to do that. More information in that URL or the QR code. And another conference that I need to announce is, yes, I have the 1 minute still. I have one more minute.
Yes, again.
Why there was no joke. So PyCon Spain is happening this year in October in Seville. It's a beautiful city. It's not summer, so you will not die of heat. So it's a good thing. The CFP is still open. You still have time. Maybe you saw ideas and you want to submit something. You also have the option to get some tickets, and they told me they are still looking for a sponsor. So thank you very much.
Hello. I'm going to talk about PyCon in France. If you are willing to go there, the background seems to be really fancy. And the tickets are free. The CFP is still open. And if you would like to visit Lyon, which is a really nice city, and French food, which is really good, this is a good place to be. Thank you.
I can second to most of that.
Hey everyone, PyData Berlin, happening September 1st to September 3rd. Hopefully it's not rainy season just yet. Yeah, we are looking for volunteers, we're looking for sponsors, and we have a lot of tech and a lot of techno, and that's it.
All right.
Okay.
All right.
Lots of stuff coming up. But we also have our first lightning talk. So welcome on stage, Luca Di Vita. Let's get him set up. Okay, round of applause. Come on, come on. There we go. Please, you can plug in your laptop. Puoi fare in inglese, come vuoi. Oh, bene, okay. So for a twist, we're going to do an exercise, even for the foreigners. Here we're going to be going through the lightning talks in Italian. You need a dongle, perhaps? Okay, I think this one you can use. Ah, questa è scomoda. Power outlet. Ma perché è così lungo? Vabbè.
In the meantime, I was drawing the next one. So. Okay, so we have Christine with 7 years, a moment. Are you here?
Christine?
Yes.
Please come in. Okay, while we'll figure out the technical stuff. Yeah, I took lessons from yesterday's. Yeah. Okay.
Yesterday, everything was smooth, though, so something had
I
happened,
wasn't
right?
smooth for one. I think I couldn't manage to make the presentation start. Okay, there we go. Hello, please welcome on stage. Okay. Do you feel like...
Sir, you don't have slides?
Do you? Okay. Come again with the name, Christine. Do you feel like spinning the wheel again? Okay. Yeah, absolutely.
Let's do that.
Ole, Margherita. Okay, let's give one more close. It's Italian, so what to do? Yes, okay, yeah. Okay, she got it. Okay.
Yeah. Yes, I'm calm. I'm not pissing myself right now. This is my first time here. Actually, my first time at any event of this kind. The last 7 years have been full of firsts for me, a long path to self-awareness that in retrospect felt like a moment, a single moment. I'm here to share a bit of that, hoping to connect with someone who feels similarly, and honestly also to feed my ego a little, which swings eternally between the most depressed and the most narcissistic ever. So I want to feel hot today, and I'm counting on you, okay?
Woo!
My name is Christine. I'm from Turin, Italy. I grew up in one of those legendary working-class southern families. That means amazing food, a caring and protective environment, but very little space for emotions and dialogue, and whatever. My family was progressive, but also rigid. There was a lot of suffering I had to unpack. In high school, things started, well, to be difficult, to feel horrible. I struggled with my image, with people, with math. I'm still not sure what was going on, but I know it was real. After a few young adult novel-style years, like interesting situation, but also literal danger, I got my diploma 2 years late. Then, in 2018, I left home. I think that was the start of the moment I was talking before. This was when I started feeling stuff, oscillating between days when I am the shit and days when I'm just feeling like shit. Leaving home was deep in the freezing water. I needed a job fast, and somehow I met my own requirement. I got one in a month. Unfortunately, unfortunately, it was in a call center. I worked there for 6.5 years. Tragic, but transformative. That job gave me economic independence at 22, which was huge after a very overprotected life. When I could finally afford it, I rented my first apartment alone and started therapy. That was a major turning point. As I told you, there was no space for all of that, so therapy taught me that I could speak, confront others, and confront myself. That same year, 2020, I also began my gender-affirming journey, another big jump. Transitioning comes with its own package, like there are a lot of benefits that come with being trans, except they are not really benefits. Being trans means asking yourself every day if there's going to be space for you in society. In Italy, if you rely on the public health system, it can feel like pausing your life and waiting indefinitely. I paused mine too, but not completely. I tried to do what I felt was sustainable for me. So I worked, I found stability, and kept trying to understand my womanhood. When I got a permanent contract about my first apartment, I was proud, but I was not fulfilled. Finally, starting hormone therapy made things more clear. I asked myself, at this point, what can I do to grow and evolve? That's when I tried Python, and from that day, the vortex just intensified. I was completely immersed. It was fun, hard, frustrating, but it didn't make me feel bad. For the first time in 15 years, I wanted to learn. Something I had found a way, somehow, I had found a way to channel all that suffering into something possibly healthy and useful. After a couple of months of self-teaching, I got into a data engineering bootcamp funded by a nonprofit foundation, something I'm super proud of. That was full-time. I was still working my previous job and still dealing with everything. It was the most intense time of my life. After that experience, I found myself being in a whole new position. I was looking for a new job in tech, close to my 30s as a trans woman. My life did a 180 in 7 years. In January, I asked for a grant to be here, and in the meantime, I landed my first job in the field, and now I'm even not a data engineer. Thank you.
Thank you. Thank you very much. Thank you very much for sharing. Remember, lightning talks are also meant for this, for sharing experiences. So thank you very much for stepping up once again. Okay, while we'll finish setting up the energy, okay, here we go. Can we get our next participant?
Messing up with the AI, Lele.
Oh, no, he's not there. Oh. Okay, where have he left? Right. Sorry.
Then we get another one. Stop legitimizing AI. Alessandro Uffreduzzi. Are you here?
Okay, so while you queue up, okay. Do you feel like spinning the wheel, Luca? Sorry? Do you feel like spinning the wheel?
The wheel.
Okay, so one level of difficulty for him, one for you. Look what we're doing the lightning talk in Italian. While riding his motorbike! Woo! You need to be riding the motorbike.
We got props.
Yeah. If you don't want to, of course. Oh, we also got props. Yes, of course. You know you need to drive safe when you get your motorbikes. Do you, right? Do you? There we go. Do you have a license? No. Okay, whatever. Okay. Let's just pretend it's not like this, okay?
And
okay,
your time starts
Cristalli, Luca, welcome.
Grazie. Scusate per chi non capisce l'italiano, ma il talk sarà in italiano. Dunque, come dal titolo parlerò di come addestrare una rete neurale con un approccio metauristico, in particolare utilizzando il Crystal, che è appunto un algoritmo metauristico nato nel 2021, quindi relativamente nuovo nell'ambito. e si basa sul processo di formazione dei cristalli, perché per chi non lo sa, i cristalli si formano con un processo ottimo, cioè la struttura molecolare di un cristallo è ottima. Quindi l'algoritmo funziona in questo modo: si creano tanti cristalli grezzi, quindi tante strutture atomiche che non sono cristalli, e tra di loro si accoppiano e evolvono fino a formare dei veri e propri, fino a formare dei cristalli, cioè fino a raggiungere l'ottimo. È un algoritmo molto buono perché permette di ricercare sia globalmente sia localmente, quindi sia le soluzioni, diciamo, locali migliorano, e sia nel contempo si continuano a cercare soluzioni in tutto lo spazio di soluzione per risolvere al meglio un problema.
Stai guidando una moto, eh?
Ah, ok, quindi devo... ok, scusate.
Brum, brum.
Brum, brum. Allora, perché ho utilizzato questo approccio piuttosto che la classica back propagation? Prima di tutto perché la back propagation c'è il rischio che vada in overfitting, cioè si adatti troppo all'addestramento, si adatti troppo ai dati all'addestramento, e questo è proprio un problema derivante dalla back propagation. Poi per via della derivabilità, la backpropagation richiede che, richiede che la funzione di attivazione e la funzione di loss siano derivabili, e questo non è richiesto dall'approccio metauristico perché non usa delle derivate. E poi per i problemi di gradient vanishing ed explosion, cioè il gradiente si azzera, quindi la rete neurale non impara più nulla, o esplode, cioè i pesi sono talmente elevati che la rete neurale è instabile. E in più non permette una ricerca locale, una ricerca globale, cioè la backpropagation funziona solo sul locale e cerca di migliorare la soluzione. Come l'ho fatto? Ho implementato il crystal. Qui sono i vari link a QR se volete vedere l'esperimento. Ho implementato il crystal assegnandogli i pesi, quindi ogni elemento della popolazione dei cristalli è in realtà un set di pesi, e tra di loro diciamo, li ho fatti evolvere con l'approccio crystal, e mi ha permesso quindi di arrivare al set di pesi che meglio risolveva il problema, e ha dato un buon risultato. Se volete vedere i risultati, ripeto, c'è il repository sia con il crystal sia con il mio esperimento, e ne parlerò anche sul mio blog scrivendolo in articolo. Grazie a tutti. Brum brum!
Very cool. Ci stai.
Thank you for driving
Leave us
with us.
the headset. We only have one. Unfortunately, Ducati didn't sponsor us this year. Drive safe.
All right.
There you go. Yes, absolutely. Oh, broccoli. Okay, so while I guess the word must be AI.
Sure.
Yes. Okay. While we wait for him to set up, let's draw next participants.
Yet another task queue. Yours. There we go.
There we go. Okay. So I would say, if you're ready, 3, 2, 1, go.
Okay, so hello everyone. My slides are going to be too long, so I'm going to skip some of them, but you can download them at the QR code that you can find. So, do you remember a time when you were excited by technology? I hope that you do if you're here. For me, it was at least 10 years ago that I last was excited by something. Usually these days when there's a new update, I feel dread. You may say that's me getting old, but actually I think it's capitalism's fault. Thank you. I didn't expect that. So I'm going to quickly run through the main topic, which is actually the tech bubbles of the last few years. So we had the slow database. Also, please give us the word crypto back. We want the word crypto back. So then we have Second Life, but for your work, Sona. That was terrible. And then we have the fully autonomous self-driving car, which is coming out any day now, and I do mean any day now. But then we got, finally we got Autocomplete++, also known as mansplaining as a service, also known as fully automated mass plagiarism, also known as a later reason to burn our planet, or the biggest tech bubble yet, which is, of course, generative AI.
Quack! Finally.
So can we stop, please, with this whole bubble? Can we stop putting AI in our keyboard and putting AI in our mice? Just can we stop doing this? Obligatory disclaimer: not all machine learning. It's not all bad. There's context, of course. I don't want to say that all machine learning is to throw away, but as a whole with the industry, there are a lot of problems. I'm going to speed run through some of them. You all know the water, energy, e-waste problems, so I won't belabor the point. But I was very frustrated that tech companies try to appear very green for years, and then as soon as they saw a way to make more profit, they threw that all away. And the idea that AI can help us solve global warming is literally magical thinking. So AI is a perfect example of socialized costs and private profits. The socialized costs come in the form of stolen content. Obviously, if I pirate a movie, I risk fine or jail, but this is okay, apparently. The other one is scraping. 65% of traffic from Wikipedia comes from bots. This other developer says this is literally a DDoS on the entire internet. The developers of curl are overwhelmed by AI slop in the form of fake security reports, and they cannot actually investigate actual security reports. But also my favorite one is that the claims for what AI can do are wildly overblown. So I really like this one from Amazon. You were supposed to be able to just go in the shop and then walk out with your items, and the AI would bill you for the items that you took automatically. But of course, that didn't work. So AI stands for actually Indians, because it was actually just 1,000 Indians who actually looked at the cameras and billed you manually. But at least they do provide entertainment in a way. Please go to this Reddit thread. It's amazing if you like watching the world burn. There are great engineers with 10 years of experience losing their mind because Copilot doesn't work. So in conclusion, when I think about technology, I think about the possibility to liberate and empower human beings and to get us to the Star Trek utopia, right? Where we don't have to do manual labor and we have more time for creativity, for learning new languages, for learning musical instruments, stuff like that. But all these tech bubbles are so disconnected from any actual human problem. And of course, that's because tech is not value neutral. And if you think your tech is value neutral, it's probably accelerating the worst part of our current status quo. You may know the quote from Mark Fisher: "It's easier to imagine the end of the world than the end of capitalism." So I would like your next project to be informed by Solarpunk. Solarpunk is a literary and artistic movement that tries to answer that question, the question by Mark Fisher, by trying to imagine a different world where technology actually helps liberate and build a better future. Thank you very much.
Thank you. Now I have to return my AI-powered toaster. Okay, coming up on stage and also spinning the wheel. Oh, feeling the challenge.
3 minutes for you.
But this also might mean that we have time for one last participant.
Yeah, I think
okay. I see the faces, but now it's done.
As my revenge, I will do another talk here with a different topic.
Okay, so the last one for today is...
The historical must-sing about winning technology and their human impact. Sarah. You here?
Yes, yeah. Please, welcome on stage. Oh, queuing up.
Okay, so...
3 minutes.
There you go.
So this is a Solve Me challenge from this paged out edition #1. So we have a Python code that works like this, and we have to provide solution to make this code work and print out the solved without crashing. So in fact, there is such solution, and it's kind of easy, so it fits in a single screen. If I format it, is it easier? No?
Yeah.
So what it does, it reads the process self maps file, and it splits it on the spaces, and then it looks for, so it splits the first field on the minus sign and looks for the W on the second field. So this is how this file looks like. So it picks up those highlighted lines. Those are writable memory addresses in the current application, in the process. Then it parses those hex strings and opens the memory file. So and then it tries to read those the data from those intervals. And what it happens, so this file represents the whole 64-bit address space. If you try to read it all, you will get an error, but you can read data from those specific intervals, which are writable. And then you try to find this, the bytecode of this function, solve me, inside this memory. So up until Python 3.11, it used to be code, and now it's code adaptive. But yeah, so it tries to find it, and when it finds it, then it overwrites something with those 4 bytes, 0, 9. So what it is, so this is the code, so this is the bytecode, and if you look at the offset 18, there's the instruction which loads the result and then jumps if this result is false. So what it could also do that on this part, but that's not interesting. So it overrides those with NOP, so no operation, and as the result, code looks like this, and it works. So that's it.
Wow. 2 minutes 15.
That's exactly how I would have done it. Thank you for it. Okay, last of today's.
I can spin it for you. Do you trust me?
Okay.
So much. And it's the veggie again.
Oh. So what's gonna the word be about?
Let's see the title.
You can choose a word for us to quack at.
No, come on, don't make it too simple.
Oh. The historical message by winning technology.
Technology could be.
Technology. Okay, let's go for technology. Technology.
Quack.
Okay, we're ready. Let's go.
Well, one of the things that I'm also interested about is how do we choose which technology do
Quack.
we
Quack.
adapt and which technologies do we
Quack.
not adapt? Because, for example, if we did a different turn in some place, maybe we wouldn't be burning the planet right now. And recently, somebody told me about the Luddites trials. Do you know who they are? You know, the people that broke the machines because they didn't agree with that. And it's really interesting because when you hear it for, it's like they were anti-technology. And then you go more and it's like, well, they didn't like their like working environments, which is also true. But then it's also like there was such a pushback against that because the biggest push for that was during the Napoleon. And the government of Britain really, really didn't want a revolution. So in the 1820, they had a trial where they decided that they're going to make the best case possible to execute the most amount of people, which was still in double digits, to say the message that fighting against what we consider progress, it's not okay. And it's really interesting reading about it, because one person was convicted of stealing food, but because they were also assumed that they participated in the breaking of the machines, they still counted as that one. And it's really interesting because what's frustrating is because if you look at the economics of the steam machine, which at that time were coal and later oil, we actually did have a solution that was economically cheaper, and that was water. The problem with water was to pound. You were location dependent, which means you actually had to take a better care of workers, and they couldn't be like, you know, like pieces that you can just replace it when you look it down. And people that actually choose water did have a bit better environment for the workers. They paid them more, they had more breaks, they provided houses and so on, but since that was like the start of the Victorian era, they also had some weird rules of like no alcohol and things like that. And some people didn't like it, and that's why they ran away. And it was interesting because that was like an economical push of why we should have steam engines and why we have an oil-based economy these days. Because when technology is really superior and it doesn't actually have any negative, like when we went from mechanical and electronic calculators, the switch basically happened in a matter of a year and two, and the entire industry collapsed, and we just replaced them because there was no negative. So
it's really interesting to see when people have to push for the technology,
Quack.
why they're pushing it. And yeah, as the previous talk about the solar punk said, I also think that generative AI is one technology somebody is pushing for some very specific reasons. Thanks.
Nice.
Thank you very much. It was a really deep session, okay, today. Really heartfelt. So in case you want to tease your brain more, I guess, don't forget they have a 5:30 in the keynote room, the quiz, the Python quiz. Yes, well, not an all-arounder quiz, just Python, okay, just Python quiz, okay.
But now coffee first. I think that's
yes,
more important.
before we
no?
leave you to fold the coffee break, I want to keep them here a bit more so the coffee ends also for them, not for me. I remind you that tomorrow we have the last session of the lightning talks. Okay. All people will not be called. We will call you tomorrow. Hopefully. Fingers crossed. I can't promise this. Thank you very much. See you tomorrow. Enjoy the pub quiz. Enjoy the keynote.